There is a place at the very bottom of the world where the wind has been blowing for so long, it seems to have forgotten how to stop. A place where the sky burns green and violet in the winter dark, and the ice stretches out so wide, so flat, so endlessly white, that standing on it you might feel less like a person on a planet, and more like a small, quiet thought drifting. This is Antarctica, and beneath it, things are sleeping. Most of us picture Antarctica as simply a frozen wasteland, a cold, empty slab of white sitting at the bottom of every map. But that picture only tells you about the surface. What lies underneath is something else entirely. Fact 1. The ice sheet itself. The ice covering Antarctica isn't just a thin glaze. It is a vast ancient accumulation that has been building, layer by layer, season by season, for roughly 34 million years. In places, it is nearly 3 miles thick. 3 miles. If you drove that distance straight down through the ice, the Empire State Building would fit inside it more than 15 times over. The sheer weight of all that ice has pressed the land beneath so hard that in some regions, the bedrock sits more than 8,500 feet below sea level. Not below the ice surface, but below the ocean's surface entirely. Antarctica isn't sitting on high ground. In many places, it has been pushed into the earth itself. And yet, for all that weight pressing down, for all that cold and silence and dark, something is moving underneath. Fact 2. Subglacial lakes. Locked beneath miles of ice, invisible to anyone standing above, there are lakes. Not tiny puddles, but vast, dark, liquid bodies of water that have been cut off from the surface for millions of years. Scientists have now identified more than 400 of them scattered across the continent. The largest, called Lake Vostok, stretches roughly 160 miles long and 30 miles wide, about the size of Lake Ontario, and sits buried under more than 2 miles of solid ice. The water inside it has been sealed away from sunlight, from air, from the outside world, since before our human ancestors first stood upright and looked at the stars. Just sit with that for a moment. Water that has not touched the open sky since the time of ancient forests, ancient seas, ancient continents shaped nothing like the ones we know today. And it is still liquid. Fact 3. Why the water doesn't freeze. You might wonder how water survives under all that ice without simply freezing solid. The answer is surprisingly gentle. The enormous pressure of the ice above actually lowers the freezing point of the water below. The same quiet physics that lets an ice skate glide across a frozen pond. And in some places, geothermal heat, warmth rising slowly from the Earth's own interior, keeps the water just barely, just tenderly, above the point of freezing. Antarctica is cold above, but the deep Earth breathes warmth underneath. Even here, even at the bottom of the world, the planet is alive. It is the middle of the night where you are, perhaps, or the quiet edge of an afternoon. And somewhere right now, beneath 2 miles of ancient ice, water is moving. Slowly, silently, in total perfect darkness. Fact 4. Subglacial rivers. Those lakes are not just sitting still. Researchers have discovered that many of them are connected, linked by rivers and channels that flow invisibly beneath the ice, carrying water from one hidden lake to another across distances of hundreds of miles. Using satellites sensitive enough to detect changes in the surface elevation of the ice above, changes sometimes as small as just a few centimeters, scientists have watched these rivers fill and drain, watched one lake empty into another, watched water shift quietly through the dark over the course of years. It is, in every sense, a hidden hydrological world, a complete water cycle running in secret in the cold and the dark beneath our feet. It is a strange and settling thing to know that the world has rooms we cannot enter, that there are places where no human eye has ever looked, where no human hand has ever reached, and yet there is motion there. There is process. There is something happening, patiently and completely, without any witness at all. Fact 5. Ancient air bubbles. The ice itself is not merely frozen water. As snow fell over Antarctica across hundreds of thousands of years, layer upon layer, century upon century, it trapped tiny pockets of the air that existed at the moment of its freezing. Those bubbles are still there, preserved in the ice like small glass jars, each one holding an exact sample of the atmosphere from its era. When scientists drill deep into the Antarctic ice sheet and extract long cylinders of ancient ice called ice cores, they can crack those bubbles open and breathe, in a scientific sense, air from 800,000 years ago. They can measure what the atmosphere contained before any human civilization existed, before agriculture, before cities, before fire in any organized sense. The ice is not just ice. It is an archive. Perhaps that is what Antarctica is, more than anything else. An archive. A place that has been quietly keeping records while the rest of the world rushed forward, writing in the language of ice and cold and pressure and time. And buried within those records are answers to questions we are only just beginning to think to ask. Fact 6. The Gamburtsev Mountains. Buried completely under the East Antarctic ice sheet. Hidden so thoroughly that no human being knew they existed until the 1950s, there is a mountain range. A full, dramatic, ancient mountain range, with peaks and valleys and ridges, rising nearly 9,000 feet from the bedrock below. They are called the Gamburtsev Subglacial Mountains. They have never seen sunlight. Not once in their entire existence has a single summit broken the surface of the ice above them. They are older than the Alps, older than the Himalayas, and yet they remain almost completely unstudied, almost completely unknown, invisible beneath a ceiling of ice 2.5 miles thick, a mountain range, sleeping. Fact 7. Ancient meteorites. And Antarctica keeps one more quiet secret worth whispering about as we settle in. Over thousands of years, meteorites have fallen from space across the entire planet, but they are extraordinarily difficult to find in most places, buried by soil, broken down by weather, lost in forests and oceans. Antarctica is different. On Antarctica, the slow movement of the ice sheet acts like a conveyor belt, carrying meteorites that landed far inland toward the surface in certain mountain regions, concentrating them, preserving them in the cold. More than 45,000 meteorites have been recovered from the Antarctic ice so far, over half of all the meteorites ever found on Earth. Some of them came from the Moon. Some came from Mars. They have been sleeping in the ice for thousands of years, waiting to be found, carrying in their ancient mineral structures the story of the solar system's very beginning. So here we are, at the edge of something enormous and unhurried, a continent that is mostly ice, but underneath that ice is an ocean of secrets. Mountains no one has climbed, lakes no one has touched, air from a world that no longer exists, rivers running in the dark. And we have only just arrived. There are still 93 more mysteries where these came from. So close your eyes if you like. Let the ice be far away and quiet. We'll go deeper. Together. There is something about ice that slows the mind in the gentlest possible way. Not the sharp cold of it, not the sting of a winter wind or the shock of cold water, but the idea of ice, the deep geological patience of it, the way it holds things, the way it remembers. We were just beginning, a moment ago, to understand what Antarctica keeps beneath its surface. The hidden lakes, the buried mountains, the ancient air, still sealed inside its frozen archive. But the ice has more to say. It always has more to say. Fact 8. How old the ice really is. We mentioned that the ice sheet has been building for roughly 34 million years, but it is worth pausing on what that number actually means. 34 million years ago, the world looked almost nothing like it does today. The continents were still settling into their current positions. There were no polar ice caps at all. The planet was significantly warmer, and Antarctica itself was covered in forests. Temperate, green, living forests. Then something shifted, the climate cooled, the forests retreated, and snow began to fall and stay. Season after season it fell. Year after year it compacted. Century after century it deepened. And it has not stopped since. The ice we are talking about, the ice pressing down on those buried mountains, sealing those ancient lakes, trapping those bubbles of prehistoric air, began as snowflakes falling on a continent that had never been cold before. And it is still here. Still here. Still adding layers, still holding on. There is something almost tender about that if you let yourself feel it. The way some things, once begun, simply continue. Quietly, without drama, without anyone watching. Fact 9. The weight of the ice and what it's doing to the land. That ice, all 26.5 million cubic kilometers of it, is so extraordinarily heavy that it has done something remarkable to the continent underneath. It has pushed the bedrock down. Not a little. In some parts of West Antarctica, the land has been depressed so far that if you removed all the ice tomorrow, the sea would rush in and cover it entirely, turning what we know as West Antarctica into a chain of islands and open ocean. The land is literally bowing under the weight of what it carries. Geologists call this isostatic depression, and they have calculated that if the ice were ever to melt away, the land would slowly, over thousands of years, rebound upward, rising like a slow, relieved breath. The continent is waiting to exhale. Underneath so much of what we think is solid and permanent, there is change happening. Change measured not in years or decades, but in the long, slow grammar of geology. Antarctica teaches that, if nothing else, that time is bigger than we usually imagine it to be. That patience is not a passive thing. It is an enormous force. Fact 10. The dry valleys. Not all of Antarctica is covered in ice, however. There are places, strange, austere, almost otherworldly places, called the McMurdo Dry Valleys, where almost no snow or ice exists at all. They are among the driest places on Earth. The surrounding mountains block the glaciers from flowing in, and a peculiar pattern of winds descends from the ice sheet above. Dry, warm winds that evaporate any moisture before it can settle. The result is a landscape of bare, wind-scoured rock, ancient lake beds, and eerie silence. Some of these valleys contain lakes that are permanently frozen on top but liquid underneath, with water so saturated with salt that it behaves almost like a different substance entirely. Scientists consider the dry valleys one of the closest analogs on Earth to the surface of Mars. They are Antarctica without the ice, and they are, in their own quiet way, just as mysterious. Mars, Antarctica, the bottom of a frozen lake. It is a remarkable thing, the way extreme places on this planet echo one another, the way the search for life in the universe keeps leading scientists back to the most remote, most hostile corners of home. Fact 11. Blood falls. In one of those dry valleys, Taylor Valley, there is a glacier, and from a crack in the face of that glacier something flows. Something that looks unmistakably, shockingly like blood. It runs red-orange down the white ice and stains the frozen ground below it. For decades after it was first discovered in 1911, no one could fully explain it. It has since been determined that deep within that glacier, there is a pocket of ancient saltwater, brine that became trapped perhaps 2 million years ago when the glacier advanced over a small ancient lake. That brine is extraordinarily rich in iron. When it finally seeps out and contacts the air, the iron oxidizes, rusts instantly. The glacier is bleeding rust. The water inside it has been sealed away for 2 million years, and when it finally meets the world again, it arrives colored like a wound. Antarctica does not always give up its secrets gently. 2 million years. Try for just a moment to hold that in your mind. Not to understand it. Understanding isn't really the goal. Just to feel the size of it. 2 million years of salt water sitting in the dark, held inside a glacier, waiting. And then, on an otherwise unremarkable afternoon, It finds a crack and it moves. Fact 12. Microbial life in impossible places. Here is perhaps the most quietly astonishing thing about bloodfalls. The water flowing from it is not sterile. It contains life. A community of microorganisms, ancient slow-metabolizing bacteria, have been living in that trapped brine for potentially millions of years, in total darkness, with no oxygen, in salt concentrations that would kill almost any other organism on Earth. They survive by processing iron and sulfur compounds in a kind of chemical breathing that has almost nothing in common with how you or I take in air. They are, in a very real sense, a living remnant of a world that no longer exists, a small, quiet colony of the ancient deep still going about their business in the dark. The discovery changed the way scientists think about life, what it requires, what it can survive, where in the universe it might be hiding. Where in the universe it might be hiding. That phrase tends to echo. Because Europa, one of Jupiter's moons, is believed to have a vast liquid ocean sealed beneath a thick shell of ice, sitting in total darkness, possibly warmed by tidal forces from the planet's gravity. And Enceladus, a moon of Saturn, actually jets water vapor from cracks in its icy surface. Scientists who study those worlds spend a great deal of time studying Antarctica. Because Antarctica is, right now, the best proof we have that life does not need sunlight. That life does not need warmth. That life does not need anything we used to think it needed, except chemistry and time and the quiet stubbornness to continue. Fact 13. Lake Whillans and the Drilling Project. In 2013, a team of scientists did something that had never been done before. They drilled through 2,600 feet of ice, using a specially designed hot water drill, to reach one of those buried subglacial lakes. Lake Whillans, a shallow, dark lake sitting beneath the West Antarctic ice sheet. They worked carefully to keep the water uncontaminated, filtering and sterilizing every drop of drilling fluid. And when they finally broke through and collected samples from water that had never been touched, never been seen, never been reached by any living thing from the surface world, they found life there too. Thousands of different species of microorganism. A thriving, invisible ecosystem, doing just fine in the permanent dark, beneath a half-mile of ice, at the bottom of the world. Life, it seems, does not wait for permission. Fact 14. What the ice cores tell us about future climate. Remember those ice cores, those long cylinders drilled from the deep ice, each one holding bubbles of ancient air? The story they tell is not only about the past. Scientists have used the record preserved in Antarctic ice to reconstruct 800,000 years of Earth's climate. Measuring ancient temperatures, ancient carbon dioxide levels, ancient volcanic eruptions, even ancient fires on other continents whose ash drifted down and settled into the ice. And what that record shows, with extraordinary clarity, is a pattern. Rising carbon dioxide in the atmosphere correlates again and again with rising temperatures. The relationship has held for nearly 1 million years of data. The ice has been keeping that particular record patiently, faithfully, and now that record is speaking, in the quiet language of chemistry and depth and time, about what is coming next. There is a certain peace that comes from knowing that the Earth is old, much older than any worry we carry tonight. That it has been through ice ages and warm ages and the slow drift of continents and the rise and fall of species without number. That it is patient in a way nothing else is patient. Antarctica knows this. It has been sitting at the bottom of the world, keeping its records, holding its secrets, sheltering its strange and stubborn life, for longer than the human mind can truly reach. And there is still so much more sleeping underneath. We have only begun to look. There is a scientist, and there have been many of them over the decades, who described the experience of standing on the Antarctic ice sheet as feeling like standing on the roof of the world, even though you are technically at the bottom of it. The ice is so high, so vast, so elevated by its own impossible depth, that the horizon seems too far away. The sky seems too large. Your own body seems, briefly, like a small and temporary thing. And perhaps that is the right way to feel in a place like this. Because Antarctica has a way of making human scale feel irrelevant. Not cruelly, but gently. The way a very old tree makes you feel young. The way a very deep river makes you feel light. Antarctica does not diminish you. It simply reminds you of proportion. And proportion tonight is exactly what we need. Fact 15. The size of Antarctica compared to what we imagine. Antarctica is the 5th largest continent on Earth. Larger than Europe, larger than Australia. It covers roughly 5.5 million square miles. But here's what most maps quietly get wrong. Because of the way flat maps distort areas near the poles, Antarctica almost always appears either absent entirely, cropped off the bottom, or strangely misshapen. The famous Mercator projection, the rectangular map that most of us grew up with, stretches Antarctica into a long white smear across the bottom edge, giving almost no sense of its true shape or size. In reality, Antarctica is a vast, roughly circular continent. And if you were to place it over a map of the United States, it would cover the entire country and spill out beyond its edges in every direction. It is hiding in plain sight on every map we own, and almost none of us have ever truly seen it. There is something almost funny about that if you are in the right mood for it. The largest landmass most of us have never really looked at, sitting right there at the bottom of every map, waiting to be noticed. Fact 16. Antarctica was not always at the bottom of the world. Long before the ice, long before the cold, Antarctica was not even in its current position. Roughly 180 million years ago, it was part of a vast supercontinent called Gondwana, joined together with what would eventually become South America, Africa, India, and Australia. They were all one thing, pressed together, warm, forested, alive with life we can now only find in fossils. Over millions of years, the tectonic plates beneath them shifted and separated, and each piece drifted slowly toward its current place on the globe. Antarctica moved south. It has been moving south, tectonically speaking, for so long that it eventually settled over the pole itself. And once it was centered over the bottom of the Earth with no warm ocean currents able to reach it from the sides, the cooling began. The forests retreated. The ice arrived. A continent that was once tropical became the coldest place on Earth. Not because the Earth changed, but because Antarctica itself moved into the cold. It moved into the cold. That is a sentence worth sitting with for a moment. Not that the cold came to Antarctica, but that Antarctica came to the cold. Drifted into it, over millions of years, the way a boat drifts slowly out of sunlight into shadow. And once it arrived, it stayed. Fact 17. The fossils frozen in time. Because of that ancient warmth, because Antarctica was once a temperate and even tropical landmass, the rock beneath the ice holds an extraordinary record of life that no longer exists there. Fossils of ancient forests, trees that grew in the warmth of a world without polar ice, have been found in Antarctic rock. Fossils of dinosaurs have been recovered from the continent, including a species found nowhere else on Earth. The bones of ancient marine reptiles, enormous creatures that swam in warm Antarctic seas hundreds of millions of years ago, have been found eroding slowly from exposed rock faces in the few ice-free areas along the coast. Antarctica is not just a frozen present. It is a fossilized past. Layer beneath layer, the continent holds the record of every world it has ever been. Every world it has ever been. That is the thing about very old places. They are not just one thing. They are everything they have ever been, stacked on top of each other, pressed together by time into something new. Fact 18. The Antarctic Peninsula and how fast it is changing. The Antarctic Peninsula, the long arm of land that reaches northward from the main body of the continent toward the tip of South America, is one of the fastest warming regions on Earth. Over the past several decades, temperatures there have risen significantly faster than the global average. Glaciers that have existed for thousands of years are retreating. Ice shelves that once held firm are fracturing and collapsing. In 2002, a floating ice shelf called Larsen B, roughly the size of the state of Rhode Island, collapsed in a matter of weeks. Scientists watching the satellite imagery described it as shocking, even for those who had been expecting it. Something that took thousands of years to form disintegrated in less time than it takes most of us to plan a summer holiday. The peninsula is Antarctica's most exposed edge, the place where the continent meets the warmer world, and it is feeling the change first. There is a particular kind of stillness that comes when you hear something like that. Not the stillness of sleep, but the stillness of a held breath. The feeling of something large, slow, and irrevocable in motion. But Antarctica is resilient in ways that are equally remarkable. And the story is not only one of loss. Fact 19. The ozone hole and its unexpected lesson. In the 1980s, scientists monitoring the atmosphere above Antarctica made a discovery that alarmed the entire world. There was a hole, not a literal opening, but a severe thinning, in the ozone layer above the continent, appearing every spring in the southern hemisphere. The culprit was identified as chlorofluorocarbons, or CFCs, chemicals used in refrigerators, aerosol sprays, and industrial processes. The ozone layer, which shields life on Earth from the most damaging ultraviolet radiation from the sun, was being eaten away by human-made chemicals that drifted upward into the stratosphere and broke apart in the extreme cold above Antarctica. What followed was one of the most successful examples of international environmental cooperation in history. The Montreal Protocol, signed in 1987, phased out the production of CFCs globally. And the ozone hole, while it still forms each spring, has been measurably recovering ever since. Antarctica, in this case, provided the warning, and the world, for once, listened. It is worth pausing on that, given the hour and the quiet, that there was a problem, and it was found, and the world responded. That the monitoring stations placed by scientists in one of the most remote places on Earth caught something that would have otherwise gone unnoticed until it was far too late. Antarctica as sentinel. Antarctica as the place where the Earth's earliest warnings appear, because the atmosphere above it is so clean, so untouched, so free of the noise of civilization that the signal comes through clearly. Fact 20. The cleanest air on Earth. Speaking of which, the air above Antarctica, particularly above the high interior of the ice sheet, is considered among the cleanest in the entire world. Because the continent is so isolated, surrounded by the Southern Ocean, and because almost no human industry exists anywhere near it, the atmosphere above it carries almost none of the particulate matter, pollutants, or aerosols that cloud the air above inhabited regions. This extraordinary clarity is not just pleasant, it is scientifically invaluable. Astronomers have placed telescopes at the South Pole and on the high Antarctic plateau precisely because the air above is so dry, so still, so transparent, that it allows observations of the cosmos that are impossible almost anywhere else on Earth. The South Pole telescope, sitting on the plateau at an elevation of nearly 10,000 feet, has been used to study the cosmic microwave background, the faint echo of the Big Bang itself, still faintly ringing through the universe nearly 14 billion years later. You can hear the beginning of the universe more clearly from Antarctica than from almost anywhere else. The beginning of the universe, heard from the bottom of the Earth. There are nights, and perhaps this is one of them for you, when the scale of things becomes, paradoxically, comforting rather than overwhelming. When the largeness of the cosmos stops feeling like a threat and starts feeling like a kind of company. You are not alone in a small room. You are part of something so vast and so old and so continuously unfolding that your particular worries, however real, are held inside something much larger than themselves. Antarctica teaches that too if you let it. Fact 21. The darkness and the light. Antarctica experiences the most extreme version of seasonal light on Earth. At the South Pole, the sun rises once a year, in September, and sets once a year, in March. For 6 months, the sun circles the horizon without ever setting, and for 6 months it does not rise at all. During the polar night, the darkness is total. Not the gentle darkness of a cloudy night, but a deep, complete, months-long absence of light. The only illumination comes from the stars, from the moon making its own slow circuit of the sky, and from the aurora australis, the southern equivalent of the northern lights, which ripples and cascades in curtains of green, purple, and red across the frozen sky. The people who winter over at Antarctic research stations, spending those dark months on the ice by choice, for science, describe the aurora as something that never entirely loses its power to stop you in your tracks. No matter how many times you have seen it, no matter how cold it is, you step outside and there it is, and for a moment you forget everything else. Fact 22. Wintering over. The human experience. There are, during the Antarctic winter, somewhere between 1,000 and a few thousand human beings on the entire continent. Most of them clustered in a small number of research stations, riding out the months of darkness and cold in the company of a small group of colleagues. The psychological experience of this has been studied extensively, because it has direct applications for long-duration space missions. The isolation, the confinement, the unchanging environment, the months without sunlight, they produce a suite of known effects. Memory and concentration can become sluggish in what researchers call the winter-over syndrome. Sleep patterns shift and fracture. Some people experience a kind of psychological narrowing, where the small social world of the station becomes everything. Others describe it as one of the most profound experiences of their lives, a stripping away of all the ordinary noise of the world, leaving something quieter and more essential underneath. Some return, year after year, drawn back by something they struggle to name. Drawn back by something they struggle to name. That is not an uncommon feeling for places that have gotten under your skin. And Antarctica has a particular talent for getting under people's skin, for lodging itself in the imagination and refusing to leave. The explorers of the early 20th century knew it. The scientists who winter over know it. Even the people who have only read about it, only seen photographs, only listened to someone describe the quality of the light at midnight in summer, even they sometimes feel it. A pull, a quiet gravitational tug toward the bottom of the world. Fact 23. The treaty that made Antarctica a place of peace. In 1959, 12 nations signed the Antarctic Treaty, one of the most quietly remarkable diplomatic achievements in modern history. At the height of the Cold War, when the United States and the Soviet Union were engaged in a tense and dangerous global standoff, those 12 nations, including both superpowers, agreed that Antarctica would be set aside. Not owned, not militarized, not exploited, dedicated entirely to peaceful scientific research and environmental preservation. The treaty prohibited military activity, nuclear testing, and the disposal of radioactive waste on the continent. It declared Antarctica a natural reserve, devoted to peace and science. 54 nations are now party to the treaty. No country owns Antarctica. It is, in a legal and political sense, the only place on Earth that belongs to no one, and therefore perhaps to everyone. The only place on Earth that belongs to no one. It is late, wherever you are. The world outside is doing whatever it does at this hour. Breathing, turning, carrying on. And at the bottom of that same world, under miles of ancient ice, in the perfect dark of a buried lake, something is moving slowly through water that has never seen the sun. The continent is still. The ice is patient. The mysteries are sleeping, one by one by one. And so, very gently, can you. There is a particular quality to the silence of very deep places. Not the silence of an empty room, or the silence of a library, or even the silence of a forest at night. Those silences are full of small sounds, if you listen carefully enough. The tick of a cooling building. The breath of wind in leaves. The distant hum of a world that never fully stops. The silence of Antarctica's deep interior is different. It is a silence with weight to it. a silence that has been accumulating for so long that it has become something almost solid, something you could lean against if you were there. Scientists who have spent time at the most remote interior stations describe a quiet so complete that they can hear their own heartbeat, their own blood moving. And beneath that silence, beneath miles of ice and rock and ancient compressed snow, the mysteries keep sleeping. We have barely scratched the surface. Fact 24, the South Pole itself and what it actually is. Most of us carry a vague mental image of the South Pole, a striped pole perhaps sticking out of flat white ice with a small sign. And there is, in fact, a ceremonial marker exactly like that, placed there for photographs and tradition. But the actual geographic South Pole, the precise mathematical point where the Earth's rotational axis meets its surface, is marked separately with a simple metal stake. And here is something quietly strange about it. That stake has to be moved every year. The ice sheet beneath the Amundsen-Scott South Pole Station is not stationary. It is slowly flowing, the way all glacial ice slowly flows, creeping across the bedrock beneath it at a rate of roughly 33 feet per year. The station and everything on it drifts. The buildings, the equipment, the ceremonial pole, the people inside drinking their coffee in the dark of winter. All of it is moving very slowly away from the true pole. And so every year at the start of the new year, a new stake is placed to mark the spot. The South Pole wanders. It cannot be pinned down. There is something endearing about that. The most fixed sounding point on the planet, the very bottom of the world, quietly refuses to stay in one place. Fact 25, the geomagnetic South Pole and why it is completely different. And it gets more complicated because there is not just one South Pole. There is the geographic South Pole we just described, the axis of rotation. But there is also the geomagnetic South Pole, the point toward which compass needles point, which is governed not by the Earth's rotation but by its magnetic field. And the magnetic South Pole is nowhere near the geographic one. It currently sits off the coast of Antarctica, out over the Southern Ocean, roughly 1,700 miles from the geographic pole. And it moves too, not just a few feet per year, but significantly, tracking the slow shifts and fluctuations of the Earth's churning liquid iron core deep below the surface. The magnetic poles have wandered dramatically over geological history, and there have been periods, many of them, when the magnetic field has reversed entirely, with magnetic north becoming magnetic south and vice versa. The last such reversal happened roughly 780,000 years ago. Another is, in the very long view of things eventually coming. The Earth's compass is not fixed. It drifts, wanders, and occasionally flips. We are navigating on a planet that is continuously rearranging its own directions. We are navigating on a planet that is continuously rearranging its own directions. That sentence could keep you company for a while if you let it. Fact 26. The subglacial Lake Ellsworth and the mission that almost worked. In 2012, a British research team attempted something extraordinarily ambitious. They wanted to do what had been done at Lake Whillans the following year. Drill through the ice and collect samples from a pristine, untouched subglacial lake. Their target was Lake Ellsworth, buried beneath 2 miles of ice in West Antarctica. They spent years planning it, designing a hot water drill capable of melting a borehole down through 2 miles of ice without contaminating the lake below. They shipped 70 tons of equipment to one of the most remote places on the continent. They drilled. And then, 300 meters short of the lake, after years of preparation and weeks of drilling in brutal conditions, the system failed. A problem with the hot water circulation meant the borehole began to refreeze faster than they could drill. They had to abandon the attempt. The lake remained untouched. It is still down there, still sealed, still waiting, and plans are underway to try again. Some mysteries resist, patiently on their own terms. Some mysteries resist on their own terms. That is worth remembering. that not every secret gives itself up simply because someone has decided to look. That there is, in the natural world, a kind of reciprocal patience required. You cannot rush a subglacial lake. You cannot hurry 2 miles of ice. Fact 27. Beneath the ice, the shape of a lost world. In recent years, using a technique called radar sounding, sending pulses of radio waves down through the ice and measuring how they bounce back, scientists have assembled the most detailed map ever made of what Antarctica looks like beneath the ice. The project is called Bed Machine, and what it has revealed is extraordinary. The bedrock beneath Antarctica is not flat. It is not simple. It is a dramatic, ancient, wildly varied landscape, with deep canyons, towering ridges, vast plains, and valleys that in some cases descend further below sea level than the Dead Sea. One subglacial canyon in East Antarctica, potentially the longest canyon on Earth, stretches for roughly 620 miles beneath the ice, plunging to depths greater than the Grand Canyon. It has never been seen by human eyes. No sunlight has ever reached its floor. And yet there it is, mapped in the data, patient and vast and completely real, waiting beneath 2 miles of ice for a visitor who may never come. A canyon longer than the Grand Canyon, deeper than the Grand Canyon, never seen by any human eye. It is one of those facts that arrives quietly and then expands slowly the longer you sit with it. The world is larger on the inside than it appears on the outside. There are rooms we have not entered. There are depths we have only heard described in numbers. Fact 28. The Southern Ocean and what makes it unique. Surrounding Antarctica is the Southern Ocean, and it is worth spending a moment with it, because it is unlike any other ocean on Earth. In 2000, it was officially designated as the world's 5th ocean, having previously been considered the southern reaches of the Atlantic, Pacific, and Indian Oceans. What makes it distinct is not just geography but behavior. The Antarctic Circumpolar Current, which flows eastward around the continent, is the largest ocean current on Earth, carrying more water than all the world's rivers combined, moving continuously around Antarctica without any landmass to interrupt it. It acts as a kind of barrier, thermally isolating the continent from the warmer oceans to the north, keeping Antarctica cold even as the rest of the world warms. It is the reason Antarctica became and stayed an icy continent. Remove that current, disrupt that barrier, and the thermal isolation breaks down. The Southern Ocean is not just surrounding Antarctica. In a very real sense, it is protecting it. Fact 29. The creatures of the deep Southern Ocean. Beneath the surface of that Southern Ocean, in the cold dark water just off Antarctica's coast, life has found ways to thrive that seem almost designed to delight a tired mind. Enormous Antarctic toothfish move slowly through the deep, cold water. Fish that can live for nearly 50 years and grow to lengths of over 6 feet, adapted to the cold with a kind of biological antifreeze in their blood. Colossal squid, not the giant squid of legend, but something even larger and stranger, have been found in Southern Ocean waters, with eyes the size of dinner plates, the largest eyes of any living animal on Earth, evolved to gather the faintest traces of light in the deep dark. Sea spiders, pycnogonids, grow to sizes in the cold Southern Ocean that would be impossible in warmer water, a phenomenon called polar gigantism, roaming the seafloor on legs that can span dinner plates. The cold, it turns out, does not prevent life from flourishing. It simply encourages it to take forms that the warmer world would never think to produce. Forms that the warmer world would never think to produce. There is a principle in biology, and perhaps in life more generally, that constraint is creative. That limitation produces novelty. That the coldest, darkest, most pressured environments on Earth are not where life gives up, but where life gets interesting. Fact 30. Emperor penguins and the winter that shouldn't be survivable. No creature embodies that principle more completely than the emperor penguin. Emperor penguins are the only animal on Earth that breeds during the Antarctic winter. Not in spite of the cold, but within it, in the middle of it, in the absolute heart of the most hostile season on the most hostile continent on the planet. The females lay their eggs in the darkness of May and June and then walk back to the ocean, sometimes 60 miles or more across the ice, to feed. The males remain. They stand on the open ice, no shelter, no food, for roughly 65 days, each one balancing a single egg on his feet, covered by a warm fold of belly skin, huddled with thousands of other males in a slow shifting mass that rotates continuously so that no individual stays on the outside in the lethal wind for too long. The temperature can drop to -40, -50 degrees. The wind can exceed 100 miles per hour. And they stand there, breathing, shuffling, waiting, holding life on their feet in the dark. When the eggs hatch and the females return, the males have lost nearly half their body weight. They have not eaten in more than 2 months. They have survived the Antarctic winter through nothing more or less than collective patience, shared warmth, and the slow turning of one body toward the center and then back out again. There is something in that which feels, at this hour, like a kind of instruction. Shared warmth. The slow turning toward the center, and back out again. The wind outside, wherever you are, is doing whatever wind does tonight. And at the bottom of the world, in the middle of a winter you will never have to survive, thousands of small warm hearts are standing in the dark, holding on. Fact 31. The icefish and blood without hemoglobin. In the cold waters just off Antarctica lives a family of fish unlike anything else with a backbone on this planet. They are called icefish, notothenoids of the family Channicthiidae, and they have evolved something so strange that when scientists first discovered it, they assumed there had been a mistake. Icefish have no hemoglobin in their blood. Their blood is not red. It is colorless, transparent, almost watery, and it carries oxygen not bound to any pigment protein but simply dissolved directly in the plasma. In the warm-blooded world, this would be catastrophic. Hemoglobin is how vertebrates move oxygen through the body, and losing it should be fatal. But in the near-freezing waters of the Southern Ocean, oxygen dissolves more readily in liquid, and icefish have evolved enormous hearts, wide blood vessels, and high blood volume to compensate. They have solved the problem of oxygen transport in an entirely different way than every other vertebrate on Earth. They are the only backboned animals in the world known to lack functional hemoglobin, a unique evolutionary experiment running quietly in the cold dark water under the ice that evolution has not tried anywhere else. A unique evolutionary experiment running quietly in the cold dark water. That is perhaps what Antarctica is in its entirety, the world's longest running experiment in what happens when things are left alone long enough. When the cold holds, and the ice accumulates, and the isolation deepens, and millions of years go by without interruption. What survives? What adapts? What evolves something so strange and so specific and so perfect for its particular impossible corner of the world that there is nothing else like it anywhere? Fact 32. The subglacial world as a model for icy moons. We touched earlier on the connection between Antarctica's hidden lakes and the possibility of life on icy moons like Europa and Enceladus. But the connection runs deeper than a simple analogy. The conditions in Antarctica's subglacial lakes, cold, dark, under pressure, with liquid water sustained by geothermal heat, cut off from sunlight for millions of years, are, as far as scientists can determine, extremely close to what exists beneath the ice shell of Europa right now. The chemistry is similar. The energy sources are similar. The depth of isolation is similar. When astrobiologists design missions to look for life beyond Earth, they use Antarctica as their laboratory and their proof of concept. The argument goes like this: if life exists in Antarctica's subglacial lakes, and we know that it does, then we have demonstrated that life can exist in conditions nearly identical to what we expect to find on Europa. And if it can exist there, then the question of whether it exists there is no longer a philosophical curiosity. It becomes a scientific question with a real answer, waiting somewhere in the cold dark of an ocean 390 million miles away. 390 million miles away. An ocean under ice, in the dark, possibly alive. Antarctica is not just the bottom of the world. It is the key to a door we haven't opened yet. A door that, if it ever swings wide, will change every answer humanity has ever given to the question of whether we are alone. That is a thought worth carrying gently into sleep. Not with urgency, not with anxiety, but with the quiet wonder of knowing that the universe is still, after everything, full of questions we haven't thought to ask yet. And that somewhere at the bottom of the world, in the silence beneath miles of ancient ice, the first hints of the answers are sleeping, patient, cold, and waiting. There is a quality to very long nights that is different from short ones. Short nights have a kind of urgency to them, the knowledge that morning is close, that the dark is brief, that you should probably be asleep already. But long nights, the kind that stretch and deepen and seem to have no particular hurry about them, those nights have a different texture entirely. They feel generous, spacious, like a room that keeps being larger than you expected. Antarctica knows about long nights. It invented them in a sense. 6 months of darkness, unbroken, unrushed, with the stars wheeling slowly overhead and the ice glowing faintly under the moon and the aurora moving in its own slow, indifferent, breathtaking way across the sky. We are somewhere in the middle of our own long night, you and I, and there is still so much of Antarctica left to explore. So let's go a little deeper. Fact 33, the ice sheet is not one thing but two. When people talk about the Antarctic ice sheet, they tend to speak of it as a single entity, one vast, continuous blanket of ice covering the continent. But scientists divide it into two distinct and very different ice sheets, separated by the transantarctic mountains, which run across the continent like a spine. To one side is the East Antarctic ice sheet, the older, larger, more stable of the two, sitting on bedrock that is mostly above sea level, containing the vast majority of Antarctica's ice and representing by far the largest single mass of ice on Earth. To the other side is the West Antarctic ice sheet, smaller, younger, less stable, and sitting largely on bedrock that lies below sea level. This distinction matters enormously, because the West Antarctic ice sheet is considered by glaciologists to be fundamentally less stable than its eastern counterpart. The bedrock beneath it slopes inward, meaning that if the ice at its edges begins to retreat, warmer ocean water can follow it inland and underneath, accelerating the melt in a self-reinforcing cycle that is very difficult to stop once it begins. The East Antarctic ice sheet is a sleeping giant. The West Antarctic ice sheet is a more restless sleeper. A more restless sleeper. We know something about that, perhaps. Fact 34. Thwaites Glacier and the glacier they call the Doomsday Glacier. Of all the ice in Antarctica, one glacier has attracted more scientific attention, more monitoring, more worry, and more breathless headlines than any other. It is called Thwaites Glacier, and it sits in West Antarctica, roughly the size of Florida, draining a massive portion of the West Antarctic ice sheet into the Amundsen Sea. Scientists have given it a nickname, the Doomsday Glacier, which is dramatic as nicknames go, and perhaps not entirely fair to the glacier itself, which is simply doing what glaciers do. But the concern is real. Thwaites is retreating. Warm water from the deep ocean is getting underneath it, melting it from below, and the rate of that melting has roughly doubled over the past 3 decades. What worries scientists most is not just Thwaites itself, but what Thwaites is holding back, a vast section of the West Antarctic ice sheet that, if Thwaites were to collapse significantly, could begin its own retreat into the ocean. The potential long-term contribution to sea level rise, if the worst scenarios played out over centuries, is measured in feet rather than inches. Not tomorrow. Not next year. Not in any time frame that should keep you awake tonight. But in the long, slow grammar of Antarctica, the same grammar that built the ice over 34 million years, the glacier is telling us something worth listening to. Worth listening to. Not worth losing sleep over on this particular night. The ice is patient, and so can we be. There is, in the study of Antarctica, a constant negotiation between urgency and perspective, between the human timescale, years, decades, a lifetime, and the geological one. Scientists who study the ice live in both timescales simultaneously, and many of them describe it as one of the more disorienting aspects of the work. You can care deeply about something that moves at a pace you will never fully witness. You can dedicate your life to understanding a process that began before your species existed and will continue long after it is gone. Antarctica demands that kind of humility, and it offers, in return, a particular kind of peace. Fact 35. The Transantarctic Mountains and what they divide. The mountain range that separates East and West Antarctica, the Transantarctic Mountains, is one of the longest mountain ranges on Earth, stretching roughly 2,200 miles from one coast to the other across the continent. In places they rise to over 14,000 feet, and in the few ice-free valleys and exposed ridgelines, they present some of the most dramatic scenery Antarctica has to offer. Dark rock faces against white ice fields, ancient sedimentary layers exposed in cliff faces like the pages of a book left open. The rock in those mountains contains fossils of Lystrosaurus, a small, sturdy, pig-like reptile that lived during the Triassic period, identical to fossils found in South Africa, India, and South America. Their presence in Antarctica was one of the early pieces of evidence that all these landmasses were once connected as Gondwana, a small, unremarkable animal that went extinct 250 million years ago turned out to be one of the key witnesses in one of geology's most important stories. The mountains hold the evidence. They always do. Fact 36. The wind and what it does to everything. If the ice is Antarctica's defining feature, then the wind is its defining force. Antarctica is the windiest continent on Earth, and the winds it produces, called katabatic winds, are unlike the wind most of us know. They are not weather systems moving across the surface. They are gravity. Cold, dense air accumulates on the high interior of the ice sheet, and then it pours, literally pours like water down a slope, down toward the coast. As it descends, it accelerates. By the time it reaches the coastal regions, it can be moving at over 200 miles per hour. At Commonwealth Bay on the East Antarctic coast, average annual wind speeds have been recorded at over 50 miles per hour, making it one of the windiest places on Earth on an average day, not just during storms. The early explorers who encountered these winds described them in terms that sound almost mythological. Douglas Mawson, who led the Australasian Antarctic expedition from 1911 to 1914, spent a winter at Commonwealth Bay and wrote of winds so powerful that walking was impossible, that men were lifted from their feet, that objects left outside simply disappeared. He called it the home of the blizzard. The wind there doesn't visit. It lives. The wind doesn't visit. It lives. There is something almost companionable about that from a safe distance. The idea of a place where the wind is a permanent resident, where it has tenure, where you are the guest and the wind is the host. Fact 37. Mawson's survival story. Since we have arrived at Douglas Mawson, it is worth spending a moment with him, because his story is one of the most remarkable survival accounts in the history of Antarctic exploration, and it has the quality of something that shouldn't have ended the way it did, which is to say, with him surviving. In November of 1912, Mawson set out from base camp on a 3-man sledging journey into the interior. His companions were Belgrave Ninnis and Xavier Mertz. On the 14th of December, Ninnis fell through a snow bridge into a crevasse, taking with him the sledge that carried most of the party's food, the tent cover, and the strongest dogs. He was never seen again. Mawson and Mertz were now 315 miles from base camp with almost no food. They began the long walk back, eating their dogs as the dogs gave out. But dog liver, it turned out, contains lethal concentrations of vitamin A, and both men began to suffer hypervitaminosis A, a condition that causes the skin to peel away, the hair to fall out, and the body to deteriorate from the inside. Mertz died. Mawson continued alone, his skin sloughing off in sheets, his hair falling out, the soles of his feet separating from the flesh beneath, for over 100 miles of Antarctic ice. He arrived at base camp to find that the relief ship had left just hours before. He spent another winter in Antarctica before finally making it home. He went back. He led another expedition years later. Antarctica, once it gets into someone, is not easily left behind. He went back. Of all the details in that story, and there are many that should, by rights, conclude with him not surviving, that is perhaps the most remarkable one. That a man who suffered what he suffered in that place under those conditions would choose to return. That Antarctica, which had taken everything from him and nearly taken him, still had some hold on his imagination that the rest of the world could not match. Some places are like that. They ask a great deal of you, and in exchange they give you something that ordinary places cannot. Fact 38. The heroic age of exploration and what drove it. Mawson was part of what historians call the heroic age of Antarctic exploration. Roughly the period between 1897 and 1922, when a series of expeditions from Britain, Norway, Belgium, Germany, Sweden, Japan, and Australia raced to map, understand, and in several cases be first to reach the South Pole. The men who undertook these journeys did so with equipment and knowledge that, by modern standards, was dangerously inadequate. Wool and canvas against Antarctic cold. Wooden ships in pack ice. Sledges pulled by dogs and men. No satellite navigation, no radio communication for much of the period. No aerial reconnaissance, no way to call for help. And yet they went, driven by a mixture of scientific curiosity, national pride, personal ambition, and something harder to name. Something that might simply be called the need to know what is there. The need to go to the edge of the known world and look over it. That impulse, ancient, irrational, irresistible, sent men into one of the most dangerous environments on Earth with canvas tents and tinned food, and some of them didn't come back, and others came back changed in ways they spent the rest of their lives trying to describe. Fact 39. Scott and Amundsen, the race to the pole. The most famous story of that era is the race between Robert Falcon Scott of Britain and Roald Amundsen of Norway to be the first to reach the geographic South Pole. Amundsen arrived first, on the 14th of December, 1911. Having chosen a different route, used skis and dog sledges expertly, and planned his expedition with a thoroughness that left very little to chance. He planted a Norwegian flag, spent 3 days confirming his position, left a tent and a letter, and returned safely to his ship. Scott arrived at the pole 34 days later, on the 17th of January, 1912, to find the Norwegian flag already flying. He wrote in his diary, "Great God, this is an awful place, and terrible enough for us to have labored to it without the reward of priority." On the return journey, Scott and his 4 companions all died. Caught by unusually severe weather, running low on fuel and food, within 11 miles of a supply depot. Their bodies and diaries were found 8 months later. History has been somewhat kind to Scott and somewhat ambivalent about Amundsen, which is perhaps unfair to both of them. Amundsen was an extraordinary planner and explorer who simply did everything right, and Scott was brave and human and unlucky and 11 miles short of surviving. Antarctica does not always distribute its outcomes according to merit. Antarctica does not always distribute its outcomes according to merit. That is a thought to hold lightly, not as a source of anxiety, but as a reminder that the world is larger than fairness, that it operates on scales and logics that do not always align with what we feel ought to happen, and that within that largeness, within that indifference, human beings have consistently chosen to go anyway, to explore anyway, to try anyway, knowing that the ice is not sentimental, knowing that the cold does not make exceptions, going anyway. Fact 40. The ghost of Ernest Shackleton. And then there is Shackleton. Ernest Shackleton led 3 expeditions to Antarctica, and the second of them, the Imperial Trans-Antarctic Expedition of 1914, ended before it properly began, when his ship, the Endurance, became trapped in pack ice in the Weddell Sea and was slowly crushed over a period of months until it sank. Shackleton and his 27 men were left on the sea ice, hundreds of miles from any land or help, with 3 small lifeboats and whatever they had managed to salvage before the ship went under. What followed is one of the most astonishing stories of leadership and survival in any setting, let alone this one. They drifted on the ice for months. They sailed the lifeboats through some of the most violent ocean on Earth to reach a barren, uninhabited island. Shackleton and 5 others then sailed an open boat, 22 feet long, 800 miles through hurricane-force seas to reach South Georgia Island, where help could be found. The navigation, performed by a man named Frank Worsley, was so precise and so unlikely given the conditions that navigators still discuss it with something approaching awe. Every man on the expedition survived. Not one was lost. Shackleton is buried on South Georgia Island at his own request. He died there in 1922, at the start of what would have been his 4th Antarctic expedition. He could not stay away. He could not stay away. There are people like that, people for whom one place on Earth becomes, inexplicably, the place that organizes everything else, that makes sense of the rest, that calls them back regardless of what it has cost them before. Shackleton found his place at the bottom of the world, in the most dangerous ocean, on a continent that crushed his ship and scattered his men on the ice. And he kept going back. It says something about Antarctica that it can do that to a person. That it can take everything and still be worth returning to. That it can be, simultaneously, the most hostile and the most magnetic place on Earth. Fact 41. The Endurance found at last. For over a century, the wreck of the Endurance lay somewhere on the floor of the Weddell Sea, in water nearly 10,000 feet deep, under some of the most difficult sea ice on Earth to navigate, in a location that was only approximately known from Worsley's careful navigation records and Shackleton's own accounts. In March of 2022, an expedition called Endurance 22 found it. Using underwater drones deployed from a research vessel navigating through heavy sea ice, they located the wreck at a depth of 9,869 feet, remarkably close to the position recorded by Worsley more than a century ago. And it was extraordinarily well preserved. The cold, dark, deep water of the Weddell Sea had protected it from the wood-eating organisms that destroy most shipwrecks in warmer oceans. The ship's name was clearly legible on the stern. The wooden hull was largely intact. Objects were visible on the deck. It looked, in the underwater footage that was released to the world, not like a ruin but like a ship that had simply settled to the bottom and decided to stay, waiting, patient and quiet and intact, in the dark of the deep Weddell Sea, for someone to come and find it. Under the Antarctic Treaty, the wreck is a protected historic monument. It will not be razed. It will not be disturbed. It will stay where it is, on the floor of the coldest sea on Earth, in the dark. In the dark. So much of Antarctica's story lives in the dark. In the dark of the polar winter. In the dark of buried lakes. In the dark of the deep ocean floor. In the dark of the ice itself, where ancient air sits sealed in its bubbles and ancient creatures swim in their cold, lightless water. But darkness, as we have been learning, is not emptiness. Darkness in Antarctica is full. It is full of life and history and mystery and the slow, patient processes of a planet doing what planets do. And we are still going. There are still 59 mysteries to find. They are sleeping, all of them, in their various darknesses, waiting for a voice to come along and wake them gently into the light. There is a theory, not a scientific one, just a human one, that the things we find most beautiful are the things that exist completely without us in mind. A sunset doesn't arrange itself for the viewer. A deep ocean doesn't light itself for the diver. A buried mountain range doesn't shape itself for the radar pulse that will one day find it. These things simply are vast, indifferent, complete in themselves, and we arrive later, small and temporary, and find them extraordinary. And the extraordinariness is entirely our own contribution. The universe made the thing. We brought the wonder. Antarctica is perhaps the purest example of this anywhere on Earth. It has been doing what it does for 34 million years without an audience. The ice has been building, the lakes have been filling, the wind has been pouring down off the plateau, the penguins have been standing in the dark. All of it proceeding with perfect self-sufficiency, requiring nothing from us, noticing nothing about us, complete. And we find it, when we finally look, more beautiful than almost anything we have made ourselves. That seems right somehow. Fact 42. The ice shelves and what they are. Around much of Antarctica's coastline, the ice sheet does not simply end at the water's edge. It extends outward, flowing off the land and out over the ocean, still attached to the continental ice behind it, but floating on the sea. These floating extensions are called ice shelves, and they fringe roughly 3/4 of Antarctica's coastline. They range from relatively modest platforms to vast, almost incomprehensible structures. The Ross Ice Shelf, the largest in Antarctica, covers an area roughly the size of France. It is a floating platform of ice up to 600 feet thick, stretching hundreds of miles out from the coast of the continent. Its seaward edge, the ice front, is a cliff of white ice rising in places 160 feet straight out of the ocean, running for hundreds of miles in an almost unbroken wall. The early explorers who first encountered it called it the Great Ice Barrier, because that is exactly what it appeared to be. A wall at the bottom of the world, blocking their passage south, so large and so uniform and so impassable that it seemed less like a natural feature and more like something deliberately placed. A wall at the bottom of the world. The early explorers had no way of knowing what it was exactly, whether it was floating or grounded, whether it went on forever, whether it was possible to get past it. Some of them sailed along its face for days, looking for a way through, running their small wooden ships along the base of that enormous white cliff and feeling, one imagines, very small indeed. Fact 43. What lives beneath the ice shelves? For a long time, scientists assumed that the water beneath the vast floating ice shelves, dark, cold, cut off from sunlight, would be essentially lifeless. Too remote, too lightless, too far from any nutrient source to support meaningful biology. In 2021, a team of British scientists drilling through nearly 3,000 feet of ice on the Filchner ice shelf made a discovery that required them to revise that assumption quite significantly. When their camera finally descended through the borehole and looked around beneath the ice shelf, in water over 160 miles from the open ocean, in complete darkness, under nearly half a mile of ice, it found a boulder on the seafloor. And attached to that boulder, living their quiet, filter-feeding lives in the lightless cold, were sponges, and stalked animals, and other stationary organisms that filter nutrients from the water flowing past them. Life, again, in a place where life had been considered essentially impossible. The scientists described the discovery as one of the most unexpected findings of their careers. Not because life under ice shelves was theoretically impossible, but because these particular animals, fixed in place, unable to move toward food sources, should have had no way to reach a location so far beneath the ice. How their larvae got there. How they established themselves in that lightless, remote cavity. What they have been eating all this time. These questions remain, at the moment, unanswered. These questions remain unanswered. There is something genuinely restful about that phrase, when you encounter it in the right frame of mind. Not every mystery needs to be solved tonight. Not every question needs an answer before morning. Some things can simply be acknowledged, held open like a hand held out in the dark, and allowed to remain unknown a little longer. The sponges on their boulder beneath half a mile of ice have been there for longer than anyone has been asking questions about them. They are not in any hurry. Fact 44. Polynya, the holes in the sea ice. Around Antarctica, in the sea ice that forms on the ocean surface each winter, there are places where open water persists, where the ice refuses to form or is continuously broken up and dispersed, leaving patches of open ocean surrounded by ice on all sides. These openings are called polynyas, from the Russian word for a natural ice hole, and they are far more than geographical curiosities. They are biological hotspots. Polynyas allow sunlight to reach the ocean surface even in winter, supporting blooms of phytoplankton that feed krill, which feed fish, which feed seabirds and seals and whales. Some polynyas are created by wind. The same katabatic winds pouring off the ice sheet push the sea ice away and keep an area of ocean continuously open. Others are maintained by upwelling of warmer, deeper water. The largest and most studied of them, the Weddell polynya, appeared in satellite images in the 1970s and persisted for 3 winters. A gap in the sea ice the size of New Zealand, sitting in the middle of the Weddell Sea in the depths of the Antarctic winter. And then it closed. And it did not reappear for over 40 years, until 2017, when it opened again briefly, for reasons that are still not entirely understood. The Weddell Sea opened a window. Scientists rushed to look through it. And then it closed again on its own schedule, without explanation. On its own schedule, without explanation. Antarctica has a habit of doing that. Of offering something, a window, a data point, a glimpse of something previously hidden, and then withdrawing it again before anyone has quite finished looking. It is a place that rewards patience and punishes the assumption that you have understood it. Every time someone announces that a particular Antarctic mystery has been solved, the ice tends to produce a new complication. Fact 45. Krill and why they hold the whole system together. In the cold, productive waters of the Southern Ocean, there is one creature that underpins nearly everything. Antarctic krill, Euphausia superba, are small, shrimp-like crustaceans, typically an inch or 2 long, that exist in such incomprehensible numbers that they are sometimes visible from space. Swarms of krill can cover hundreds of square miles of ocean surface, turning the water a deep reddish-brown. The total biomass of Antarctic krill, the combined weight of all the krill in the Southern Ocean, is estimated at somewhere between 100 million and 500 million tons, making them one of the most abundant animal species on Earth by total mass. Every significant animal in the Antarctic ecosystem ultimately depends on them. Baleen whales eat almost nothing else during their Southern Ocean summers. Crab-eater seals, the most numerous seal species on Earth, eat almost nothing else their entire lives. Penguins eat them. Seabirds eat them. Fish eat them. The entire food web of the Southern Ocean is, in a sense, a structure built on top of these small, translucent, endlessly numerous creatures, performing their slow vertical migrations through the water column, grazing on phytoplankton in the surface waters, sinking carbon into the deep ocean as they go. They are the hinge on which the whole system turns. The hinge on which the whole system turns. There is something quietly instructive about that. About how often the most important element in a complex system is not the largest or the most dramatic, but the most numerous. Not the whale, but the krill. Not the glacier, but the snowflake that fell 800,000 years ago and is still here. Not the grand gesture, but the small persistent thing that shows up every day without fail and does what it does and holds everything else up. Fact 46. The Whale Highway and the Return of the Giants. For much of the 20th century, the waters of the Southern Ocean were one of the most intensively hunted places on Earth. Industrial whaling operations, beginning in the early 1900s and accelerating dramatically after World War II, targeted the great whales of the Southern Ocean. Blue whales, fin whales, humpbacks, sperm whales, with a thoroughness that brought several species to the edge of extinction. Blue whales, the largest animals ever known to have existed on Earth, were reduced from an estimated population of over 200,000 to perhaps a few hundred individuals in the Southern Ocean by the time commercial whaling was brought under control. The International Whaling Commission eventually imposed a moratorium on commercial whaling in 1986. And since then, slowly, incompletely, but measurably, the whales have been coming back. Humpback populations in the Southern Ocean have recovered significantly. Blue whale sightings have increased. The ocean that was stripped of its giants is, very gradually, refilling. The whales are returning to their ancient feeding grounds in the cold, krill-rich water around Antarctica. The highway is reopening. It is one of the more hopeful things happening on this planet at the moment, if you are in the market for hopeful things, which at this hour seems like a reasonable thing to be. The highway is reopening. Let that settle for a moment. A thing that was nearly destroyed over the course of a century, turned back from the edge over the course of decades, and now returning. Not all the way, not yet, perhaps never entirely, but returning. Moving through the cold, dark water in the direction of recovery. The largest animals that have ever lived on Earth, swimming south again toward the ice. Fact 47. The acoustic landscape of the Southern Ocean. Sound travels differently in water than in air. Faster, farther, and in the ocean sometimes astonishingly far. The Southern Ocean has its own acoustic landscape, shaped by the temperature and depth of the water, the presence of ice, and the creatures that live in it. Blue whales communicate with calls so low in frequency that they fall below the range of human hearing. Infrasound, felt more than heard, and those calls can travel thousands of miles through deep ocean water. Researchers studying the acoustic environment of the Southern Ocean have recorded not just whale calls but the sound of icebergs grinding against each other, the creak and groan of sea ice forming and breaking, the collective noise of millions of krill moving through the water. There are research hydrophones, underwater microphones, placed in the Southern Ocean that record continuously, and the soundscape they capture is, in its own way, as complex and layered as any environment on Earth. When scientists play back recordings made near the Antarctic coast, they describe a world that is anything but silent. The ice talks. The whales talk. The ocean itself, under pressure and temperature, makes sounds that carry for hundreds of miles with no one to hear them. A conversation between enormous things, conducted in frequencies we were never really meant to receive. A conversation between enormous things, conducted in frequencies we were never meant to receive. There are whole layers of the world operating just outside the range of what we can perceive. Sounds too low to hear. Light outside the visible spectrum. Magnetic fields too subtle to feel. The Earth is doing so much continuously that we simply don't have the instruments for. And Antarctica, being so large and so old and so full of processes operating on inhuman scales, is doing more of it than almost anywhere else. Fact 48. Icebergs and the long journey north. When pieces of ice break off from Antarctica's ice shelves and glaciers, a process called calving, they become icebergs and they begin a journey. Not a purposeful one, not a directed one, but a journey nonetheless, driven by wind and current and the slow logic of the Southern Ocean. Antarctic icebergs can be extraordinary in scale. The largest ever recorded, designated B-15, calved from the Ross Ice Shelf in the year 2000 and measured roughly 170 miles long and 25 miles wide, with a surface area larger than the island of Jamaica. It drifted slowly, breaking into pieces over years, eventually sending fragments as far north as the open South Atlantic. Icebergs from Antarctica have been tracked for years as they move, carrying their cargo of ancient ice, sometimes containing air bubbles and dust and fragments of biological material that fell onto the ice sheet thousands of years ago, northward into warmer water, where they gradually melt and release that cargo into the ocean. An iceberg is Antarctica in transit, a piece of the deep past, moving slowly through the present, dissolving as it goes. A piece of the deep past, moving slowly through the present, dissolving as it goes. That is, in a sense, what all things are. Every old thing carries something ancient inside it and moves, however slowly, toward its eventual dissolution. The iceberg is just honest about it. It wears its age on the outside. You can see, if you look closely, the layers of its accumulation, the faint bands of different ice, different snow, different years compressed together into something that floats and drifts and quietly, inevitably becomes the sea. Fact 49. The role of Antarctica in driving global ocean circulation. Perhaps the most consequential thing Antarctica does, more consequential even than all its mysteries and its history and its extraordinary wildlife, is something almost no one thinks about. Antarctica drives the circulation of the entire global ocean. In the waters around Antarctica, particularly in the Weddell Sea, surface water is cooled so intensely by the Antarctic atmosphere that it becomes extraordinarily dense, cold and heavy and salty. This dense water sinks. It sinks to the very bottom of the ocean and then flows northward along the ocean floor, spreading out across the deep basins of the Atlantic, Pacific, and Indian Oceans. This process, called Antarctic bottom water formation, is one of the primary engines of the global thermohaline circulation, the vast system of deep ocean currents that distributes heat, oxygen, and nutrients around the entire planet. The cold water that sinks off Antarctica today will eventually resurface somewhere in the North Atlantic or the North Pacific, but not for hundreds or in some cases thousands of years. Antarctica is, in this sense, the deep engine of the ocean, the cold heart that keeps the whole system moving. A change in how efficiently it forms that cold, dense water, and warming is already affecting this, sends ripples through the entire global ocean circulation on timescales that extend for centuries. The cold heart that keeps the whole system moving. It is extraordinary when you follow the connections far enough, how many of them lead back to Antarctica. The climate record in the ice cores, the carbon cycle in the krill, the ocean circulation in the sinking cold water, the biology of icy moons in the microbes of subglacial lakes. Pull almost any thread in the Earth system far enough and eventually it leads you south to the ice, to the cold, to the continents sitting at the bottom of the world quietly running things. We don't always know from inside a system where the center of it is. We tend to assume the center is wherever we are. But the Earth's center of gravity, climatically, oceanographically, biologically, may be a great deal further south than most of us have thought to look. Fact 50, the halfway point. And here we are, exactly halfway. 50 mysteries have found their way from the ice into the air between us. 50 facts have been lifted from the cold dark of the continent and brought, gently, into whatever light is with you right now. There are 50 more where those came from. 50 more mysteries sleeping under the ice, waiting to be told. The buried lakes and the ancient fossils, the wandering poles and the crushing ice, the blind fish and the sinking water and the whales returning to their ancient highway. All of this is only half the story. But half a story told slowly on a long quiet night is already something considerable. And there is no rush. The ice has been there for 34 million years. The mysteries are not going anywhere. They will be exactly where we left them, patient and cold and perfectly preserved, whenever we are ready to continue. For now, if the night has done what long nights do, if the voice has become a kind of current you are drifting on rather than a thing you are actively listening to, then perhaps that is the right place to rest. The other 50 are waiting. They can wait a little longer. Welcome back to the ice. Or perhaps you never left. Perhaps you have been here the whole time, drifting somewhere between listening and sleeping, between the words and whatever is underneath them. That is exactly the right place to be. We are past the halfway point now. 50 mysteries behind us. 50 ahead. The continent is still down there, doing what it does, building its ice, running its ocean, sheltering its strange creatures in the cold. The lakes are still sealed. The mountains are still buried. The wind is still pouring off the plateau in the dark. And we still have so much to find. Fact 51. The ice has a memory of every major volcanic eruption on Earth. We have talked about how the ice cores preserve ancient air, bubbles of atmosphere sealed inside the accumulated snow of hundreds of thousands of years. But the ice preserves more than air. It preserves ash. When volcanoes erupt anywhere on Earth with sufficient force, they send plumes of ash and sulfur dioxide high into the stratosphere, where it disperses and eventually settles, falling slowly, invisibly, over every part of the planet, including Antarctica. Each major eruption leaves a thin chemical layer in the Antarctic ice, a faint stripe of sulfate and ash, precisely dated by its depth in the core. Scientists have used these volcanic markers as anchor points for dating the ice record, matching the chemical signatures to known historical eruptions. The eruption of Tambora in Indonesia in 1815, the largest volcanic eruption in recorded history, which caused the following year to be known as the year without a summer across much of the northern hemisphere, is clearly visible as a layer in the Antarctic ice. So is Krakatoa. So are eruptions that occurred before any human civilization had the capacity to record them. The ice has witnessed every major convulsion of the Earth's geology for 800,000 years, and it has noted them all, faithfully, in the language of chemistry and depth. It has noted them all. There is something almost moving about that level of fidelity. The ice did not choose to keep records. It simply accumulated layer after layer, and in doing so it became the most comprehensive archive the Earth has ever produced. Not because it was trying to remember, but because that is what happens when something is patient enough and cold enough and undisturbed enough. Memory accretes, without effort, without intention, simply as a consequence of continuing. Fact 52. The strange behavior of Antarctic snow. The snow that falls on Antarctica is not quite the snow most of us know. In the interior of the continent, where the air is so cold and so dry that it holds almost no moisture at all, the snowfall is extraordinarily light, the equivalent of perhaps 2 inches of rain per year, making the deep interior one of the driest places on Earth by precipitation. What falls is not the large soft flakes of a temperate snowstorm but something finer and harder. Tiny crystals of ice, almost like sand, that fall from a sky that often appears perfectly clear. This phenomenon, precipitation falling from an apparently cloudless sky, is called diamond dust, and it is one of the stranger and more quietly beautiful things about the Antarctic atmosphere. On calm days in the interior, you can stand in what appears to be a clear blue sky and still feel these tiny ice crystals falling on your skin, catching the sunlight, making the air itself seem to glitter. The atmosphere is so cold that ice crystals form directly from the water vapor without the need for clouds to organize them. The sky sparkles in the cold, with nothing visible to cause it, like a very subtle and continuous magic trick. Diamond dust falling from a clear sky. That image is worth keeping for a moment. The idea that even the air at the bottom of the world, in the coldest and driest place on Earth, is doing something beautiful, something that catches light and sparkles, even when there is almost no one to see it. Fact 53. The Antarctic convergence and the invisible boundary. If you were sailing south from any direction and crossed into Antarctic waters, there would be a moment, a specific, identifiable, somewhat dramatic moment, when you would know you had arrived. Not because of any landmark or any sign, but because the water temperature would drop abruptly, the sea state would change, and the color of the ocean itself would shift. This invisible boundary is called the Antarctic convergence, or the polar front, the line where the cold surface waters of the Southern Ocean meet and sink beneath the warmer waters of the subantarctic. It runs in a rough circle around Antarctica, between roughly 50 and 60 degrees south latitude, and it is one of the most biologically significant boundaries in the ocean. The cold water on the Antarctic side is rich in nutrients, upwelled from the deep by the circular currents of the Southern Ocean, and the collision of cold and warm water at the convergence creates conditions of extraordinary biological productivity. Albatrosses and petrels congregate there. Whales feed there. The line between one ocean world and another, invisible on any map, is one of the most important ecological boundaries on the planet. An invisible line on the ocean that changes everything on either side of it. The world is full of those if you look for them. Thresholds that don't announce themselves. Boundaries you only recognize once you have crossed them. the place where the cold water meets the warm, the place where the ice begins, the place where the last light of evening tips over into proper dark. We crossed a threshold ourselves a little while ago, past the halfway point of this journey. The second half always feels different from the first. Something has loosened. The familiarity has settled in. The voice and the dark and the ice have become, by now, a kind of landscape, you know. Fact 54. The cosmic ray detector buried in the ice. Beneath the South Pole Station, drilled into the deep ice of the Antarctic Plateau, is one of the most unusual scientific instruments ever built. It is called IceCube, and it is a neutrino detector, a device designed to catch one of the most elusive particles in the universe. Neutrinos are subatomic particles produced by violent cosmic events, supernovas, black holes consuming matter, gamma ray bursts, and they travel through the universe at nearly the speed of light, passing through almost everything without interacting. Billions of neutrinos pass through your body every second without you noticing, without them noticing. IceCube uses the ice itself as its detector. It consists of 5,160 individual sensors embedded in the ice at depths between 1,400 and 2,500 meters, arranged in strings across a cubic kilometer of ancient Antarctic ice. Very occasionally, a few times per year, a neutrino traveling through the ice will interact with a water molecule and produce a tiny flash of blue light, called Cherenkov radiation, which the sensors detect. By analyzing those flashes, scientists can determine where in the universe the neutrino came from. IceCube has detected neutrinos from outside our galaxy. Particles that have traveled billions of light years through the universe, pass through the Earth, and announce their arrival with a faint blue flash in a cubic kilometer of 2-mile-deep Antarctic ice. The ancient ice is listening to the universe. The ancient ice is listening to the universe. It was already keeping records of volcanic eruptions and ancient atmospheres and layers of cosmic dust. Now it turns out it is also catching messages from outside the galaxy. Fragments of information from the most violent events in the known universe, decoded in the cold dark a mile and a half below the South Pole. Antarctica, it seems, was always meant to be an archive. The universe just keeps adding to the collection. Fact 55. The gravitational anomalies beneath the ice. The ice sheet of Antarctica is so massive, and the bedrock beneath it so varied, that the gravitational field above the continent is measurably uneven. Dense rock pulls more strongly than empty space or sedimentary basin, and sensitive instruments, both ground-based and satellite-mounted, can detect these minute variations in gravity and use them to map what lies beneath the ice. This technique, called gravimetry, has revealed the presence of large sedimentary basins beneath parts of Antarctica that could contain significant deposits of oil and natural gas. It has helped map the subglacial bedrock in regions where radar cannot easily penetrate. And in one striking case, it has revealed what appears to be the remnant of a massive impact crater buried under more than a mile of ice in Wilkes Land, East Antarctica. A roughly circular structure approximately 300 miles across, which some researchers believe may be the scar left by a meteorite impact so large that it contributed to the mass extinction event at the end of the Permian period, 252 million years ago. The largest mass extinction in Earth's history, the Great Dying, which wiped out more than 90% of marine species and 70% of terrestrial vertebrate species, may have been triggered, at least in part, by something that hit where Antarctica now sits. The scar is still there, buried under the ice, waiting for confirmation that may take decades to arrive. Waiting for confirmation that may take decades to arrive. 252 million years of waiting, and a few more decades is nothing. The crater is patient. It has been patient since before the dinosaurs existed. It will still be there when the confirmation finally comes. Fact 56. The peculiar flatness of the East Antarctic Plateau. The East Antarctic ice sheet, in its interior, achieves something that is almost impossible to convey in words. a flatness so extreme and so extended that it produces a kind of spatial disorientation in the people who experience it. The polar plateau, at an elevation of around 10,000 feet above sea level, is so flat and so uniform and so unvarying in every direction that the human visual system, which depends on contrast and reference points to construct a sense of space, effectively gives up. There is no near and far. There is no landmark to fix your position. The horizon is a perfectly even line in every direction, and the sky above is a dome of equal emptiness. People who have traveled across it describe a feeling of moving without going anywhere, of walking for hours and feeling that the landscape has not changed in any perceivable way. In whiteout conditions, when cloud cover diffuses the light so completely that the surface and the sky merge into a single uniform whiteness, it is impossible to see the ground beneath your feet. People have fallen into depressions in the ice that they never saw coming because there were no shadows to reveal them. The interior of Antarctica erases the visual cues that human beings need to feel located in the world. It is perhaps the closest thing on Earth to the experience of floating in open space. The closest thing on Earth to floating in open space. There is a particular kind of peace in that image at this hour. The idea of a place so white, so even, so undifferentiated that the usual machinery of orientation simply quiets down. No here and there, no near and far, no landmarks to navigate by, no visual noise to process. Just whiteness in every direction, and the soft sound of your own breathing. That sounds, if you let it, a great deal like sleep. Fact 57. The ice dome and the coldest temperature ever recorded. At a place on the East Antarctic Plateau called Dome A, the highest point of the Antarctic ice sheet, sitting at 13,428 feet above sea level. Conditions exist that are, by most measures, more extreme than anywhere else on the surface of the Earth. The air is so thin, so cold, and so dry that it behaves almost like the atmosphere of another planet. But the coldest temperature ever recorded on Earth was not at Dome A, nor at the South Pole, nor at any of the established research stations. It was measured by satellite, in a small region of the East Antarctic Plateau near a place called Ridge B, in the winter of 2010, and confirmed and extended in subsequent satellite measurements. The temperature recorded was minus 98 degrees Celsius, minus 144 degrees Fahrenheit. At that temperature, the moisture in your breath would freeze before it left your lips. The cells in exposed skin would crystallize. It is a temperature at which the concept of cold stops being a sensation and becomes something more fundamental. A physical condition of the universe, one step closer to absolute zero, which is as cold as anything can possibly be. And it is occurring quietly, regularly on the surface of our own planet at the bottom of the world, in the dark of the polar night. One step closer to absolute zero. On the surface of our own planet. The universe is full of extremes, and most of them are far away. In the hearts of stars, in the void between galaxies, in the crushing centers of neutron stars. But some of them are here. Right here on Earth, in the places we have not fully explored, in the cold, dark corners that most of us will never visit. The extremes are closer than we think. The universe is doing its most extraordinary work, in some cases, right below our feet. Fact 58. The ice-free oases and the mummified seals. In the dry valleys we visited earlier, those strange, wind-scoured, ice-free regions of Antarctica, there are mummies. Not human ones. Seal mummies. Crab-eater seals and Weddell seals, long dead, their bodies perfectly preserved by the cold and the dry air, sitting on the valley floors miles from the coast, miles from any water, in places where a living seal has no business being. Some of these mummified seals are hundreds of years old. Some may be thousands of years old. How they got there is not entirely clear. Seals occasionally wander far inland, possibly disoriented, and die when they can't find their way back. But the preservation is so extraordinary that their fur is still intact, their features recognizable, their bodies not decayed but simply desiccated. dried by the wind and the cold into a kind of natural taxidermy. They lie in the valleys, looking outward, perfectly still, as though they simply lay down one day and decided to stay. The dry valleys preserve them indefinitely. There is no mechanism for decay. They will be there for as long as the conditions hold, which could be thousands more years. The valleys are collecting them slowly over time, a quiet gallery of the continent's wanderers, preserved exactly as they were at the moment they stopped. Preserved exactly as they were at the moment they stopped. There is something tender in that and something strange. The idea of wandering far from where you belong, lying down in an impossible place, and being kept perfectly, indefinitely, exactly as you were. The cold and the dry air asking nothing of you, just holding you as you were for as long as it takes. Fact 59. The role of Antarctica in Earth's albedo. One of the less obvious but enormously important things Antarctica does for the planet is to reflect sunlight back into space. The white surface of the ice sheet, and the sea ice surrounding the continent, acts as a giant mirror, bouncing a significant portion of the solar radiation that reaches it back out into the atmosphere rather than absorbing it as heat. This reflectivity is called albedo, and Antarctica's albedo is among the highest of any surface on Earth. The ice sheet reflects roughly 80% of the sunlight that hits it. Ocean water, by contrast, reflects only about 6%, absorbing most of the solar energy that reaches it as heat. This difference means that the presence or absence of ice and snow in Antarctica has a direct and significant effect on how much heat the Earth absorbs overall. As sea ice around Antarctica decreases, as the mirror shrinks, more sunlight is absorbed by the darker ocean water beneath it, warming the ocean further, melting more ice, shrinking the mirror further. It is another of those self-reinforcing feedbacks that the Earth system contains. A loop that, once moving, is difficult to stop. Antarctica's whiteness is not just beautiful. It is functional. It is one of the planet's primary thermostats. One of the planet's primary thermostats. We live on a planet that regulates itself, that has, over billions of years, developed feedback mechanisms and cycles and buffers that keep conditions within a range compatible with life. Antarctica is one of the most important of those mechanisms. It sits at the bottom of the world and reflects the sun and drives the ocean and keeps the air records and anchors the whole system in ways that most of us never think about, in our ordinary daily lives on our ordinary inhabited continents far to the north. But it is there. It has always been there. And it is doing its work quietly and continuously, without any of us needing to understand it or even to know about it, which is, in its way, a kind of relief. Not everything requires your attention. Not everything needs to be managed or understood or worried about. Some things are simply running deep and cold and old and competent, far away from where you are lying right now. The planet's thermostat is set. The ocean circulation is running. The ice is reflecting the sun. The neutrino detector is listening to the universe. The mummified seals are lying in their valley. The whales are moving through the cold water toward their ancient feeding grounds. Everything is proceeding, and you can rest. There is a word in Japanese, ma, that roughly translates as the pause between things. The silence between notes that makes the music. The space between words that gives them room to breathe. The gap between one thought and the next, where something unnamed lives. Antarctica is, in many ways, a continent made of ma. It is the pause at the bottom of the world. The silence between the inhabited continents. The gap in the map that most of us pass over without stopping, never quite noticing that we have skipped something enormous. But the pause is not empty. It never was. The silence is full of things that have been happening patiently in the gap, in the cold, in the dark, for longer than we have been here to notice them. We are still in that gap, still moving through it, still finding things. Let's keep going. Fact 60. The strange tides beneath the ice shelves. The ocean beneath Antarctica's floating ice shelves is not still. It is subject to tides, the same gravitational pull of the moon and sun that drives tides everywhere on Earth. And those tides move the ice. The entire floating mass of an ice shelf rises and falls with the tidal cycle, flexing at its grounding line, the point where floating ice meets the bedrock beneath and transitions from shelf to glacier. That flexing, repeated twice daily across thousands of years, creates stresses in the ice that scientists are only beginning to fully map. But the tides do something else beneath the ice shelves as well. They drive currents. The rhythmic pushing and pulling of tidal water beneath the floating ice creates mixing and circulation in an environment that would otherwise be very still. And that circulation carries heat. Warm water, pulled in by tidal currents, reaches places beneath the ice shelf that it would not reach through simple diffusion. It touches the underside of the ice. It melts. The moon, 239,000 miles away, is quietly, methodically, contributing to the melting of Antarctic ice simply by doing what it has always done, pulling on the ocean with its gravity twice a day as reliably as anything in the solar system. The ice feels it. It has always felt it. We are only now beginning to understand how much. The moon is melting the ice. From 239,000 miles away, through gravity alone, through the simple faithful rhythm of the tides, the moon is touching Antarctica. Everything is connected to everything, across distances that should make connection impossible. The moon pulls the ocean. The ocean moves under the ice. The ice melts a little, somewhere in the cold dark beneath a floating shelf. A fact that is, in its quiet way, one of the more beautiful ones we have encountered tonight. Fact 61. The ice sheet's internal layers and what they reveal. When radar pulses are sent down through the Antarctic ice sheet, the same technique used to map the bedrock below, they also bounce back from internal layers within the ice itself. These internal layers are like the rings of a tree or the strata of a sedimentary rock face, each one representing a surface that was once the top of the ice sheet, buried by subsequent snowfall and compressed over time. By mapping these internal layers across vast regions of the ice sheet, scientists can reconstruct the history of how the ice accumulated, how it flowed, and how conditions changed over time. In some places, the internal layers are smoothly horizontal, undisturbed, evidence of steady, gradual accumulation over long periods. In others, they are folded and buckled, twisted by the flow of ice over uneven bedrock below, creating patterns that look, in radar cross-section, almost like the folds of fabric or the swirls of marble. Deep within the ice, near the base, the oldest layers have been compressed and distorted almost beyond recognition, stretched and thinned by the slow flow of ice over hundreds of thousands of years. The interior of the ice sheet is a geological document written in layers, and scientists are still learning to read it fluently. A geological document written in layers, still being read. There is something in that worth sitting with. The idea that understanding is not an event but a process. That the document has been there all along. Patient, complete, fully written, and the reading of it is what takes time. What takes effort? What requires generation after generation of people pointing instruments at it from above and slowly deciphering what it says. Fact 62. Microplastics in the Antarctic snow. In 2022, scientists published a study reporting something that should perhaps not have been surprising, given everything we know about how thoroughly human civilization has spread its byproducts across the planet, but which was nonetheless striking to encounter. They found microplastics in Antarctic snow, not at the edges of the continent, near research stations or shipping routes, but deep in the interior, in freshly fallen snow collected from remote areas of the Ross Ice Shelf, far from any significant human presence. Microplastics, tiny fragments of plastic smaller than 5 millimeters, produced by the breakdown of larger plastic objects, had been carried to Antarctica by the wind and by ocean currents, and were falling with the snow onto the pristine ice of the most remote continent on Earth. The concentrations were low, far lower than in populated regions, but they were there. They were measurable. The archive that has been keeping faithful records of the Earth's atmosphere for 800,000 years has now begun recording the Anthropocene, the age of human influence, in the only language it knows. The ice is noting what we have done. It is adding our layer to the record. Faithfully, without judgment, as it has always done. Faithfully, without judgment. The ice does not editorialize. It does not express alarm or disappointment. It simply records. A layer of volcanic ash here. A layer of nuclear fallout from 1950s weapons testing there. That layer, too, is clearly visible in the ice cores, a sharp chemical marker that scientists use as a precise date anchor. And now, a faint dusting of plastic, falling with the snow onto the deep interior, being buried under the next year's accumulation. The ice will keep that record for as long as the ice lasts. Long after the civilization that produced the plastic has changed beyond recognition, the layer will be there, readable by whatever instruments exist to read it. The Earth's archive is thorough. It misses very little. Fact 63. The Antarctic ozone hole and ultraviolet light. We talked earlier about the ozone hole, its discovery, the Montreal Protocol, its slow recovery. But there is a dimension of the ozone story that is worth returning to, because it touches something quite specific about the Antarctic environment. During the spring, when the ozone hole is at its largest and the sun returns to Antarctica after the winter darkness, the ice sheet is exposed to elevated levels of ultraviolet radiation, far higher than would occur with a healthy ozone layer overhead. This UV radiation penetrates into the surface layers of the snow and ice, and into the surface waters of the Southern Ocean. Phytoplankton near the ocean surface, the microscopic algae that form the base of the Southern Ocean food web, are sensitive to UV radiation, and studies have shown that the elevated UV associated with the ozone hole has affected phytoplankton productivity in Antarctic waters. Since phytoplankton are the foundation of the krill population, which is the foundation of everything else, the ozone hole is not just a chemical curiosity in the upper atmosphere. Its effects cascade down through the food web, touching krill and penguins and whales and seals in ways that are still being fully traced. The recovery of the ozone layer matters to every living thing in the Southern Ocean. The atmosphere and the ocean are not separate systems. They are one system, responding to each other, connected at the surface by every molecule of gas that crosses the boundary between air and water. Connected at the surface by every molecule that crosses the boundary. The more you look at any natural system, the more boundaries dissolve. The ice and the ocean, the atmosphere and the sea, the deep bedrock and the water table above it, the cosmic rays from distant galaxies and the ice that catches them 2 miles below the surface. Everything is permeable. Everything is in conversation with everything else. The idea of a closed system, a thing that exists in isolation, fully separate from its surroundings, turns out at every scale you examine it to be an abstraction. In reality, everything is leaking into everything. Fact 64. The midnight sun and what it does to the ocean. During the Antarctic summer, the sun does not set. 4 months, it circles the horizon. Sometimes higher, sometimes lower, but always present, casting its light at a low angle across the ice and the ocean for 24 hours a day. And that continuous light does something remarkable to the Southern Ocean. It drives one of the most intense and productive blooms of phytoplankton on the planet. With sunlight available at all hours, and the cold upwelled water of the Southern Ocean delivering nutrients in extraordinary concentrations, phytoplankton multiply explosively in the summer months. Vast blooms visible from space, turning stretches of the ocean green, producing oxygen, fixing carbon, feeding the krill that feed everything else. The Antarctic summer is the engine of the Southern Ocean's extraordinary productivity. All of it powered by a sun that refuses, for a few months, to go below the horizon. A sun that works the night shift. A sun that, in this one place on Earth, doesn't stop. A sun that doesn't stop. working through what should be the night, feeding a bloom that feeds an ocean that feeds the base of the largest marine ecosystem on the planet. There is something almost generous about it, the image of a sun that just keeps going, that doesn't rest, that pours its light into the cold water month after month and allows something extraordinary to grow there. Though for our purposes tonight, the sun that never sets is very far away. Down here, in whatever darkness surrounds you, the ordinary rules apply. The sun has set. The dark is here. And the ice, as always, is patient. Fact 65. The discovery of Antarctica itself. It is worth pausing somewhere in the second half of this journey to note that Antarctica was the last continent on Earth to be discovered by human beings. For centuries, millennia, even, people suspected there was a large southern landmass. Ancient Greek philosophers had reasoned that there must be a great southern continent to balance the known landmasses of the north. Medieval and Renaissance mapmakers drew it in, a vast, imagined land they called Terra Australis Incognita, the unknown southern land, depicted sometimes as temperate and inhabited, populated by speculation rather than observation. James Cook circumnavigated the Antarctic region in the 1770s, crossing the Antarctic Circle and pushing further south than any known expedition before him, but never sighting the continent itself. He concluded that even if land existed further south, it would be locked in ice and of no practical value. The continent itself was not definitively sighted until 1820, within a few days, as the historical record stands, by 3 separate expeditions independently. A British naval officer named Edward Bransfield, an American sealer named Nathaniel Palmer, and a Russian naval officer named Fabian von Bellingshausen. All 3 saw it within weeks of each other. After thousands of years of speculation, the unknown southern land announced itself to 3 different people almost simultaneously, as though it had simply decided the time had come. As though it had simply decided the time had come. The continent waited, in other words, until it was ready to be found. 200 years ago, it was still unknown. The greatest landmass that human civilization had never seen was sitting at the bottom of every ocean, present and patient and entirely undocumented. 2 centuries is not very long by Antarctic standards. The ice has been here 34 million years. The 2 centuries of human knowledge of this place is a layer so thin it would not even register in an ice core. Fact 66. The first winter over and what it cost. The first human beings to spend a winter in Antarctica did not do so entirely by choice. In 1898, the Belgian Antarctic expedition, aboard a ship called the Belgica, became trapped in pack ice in the Bellingshausen Sea and drifted, locked in, through the entire Antarctic winter. The crew had not prepared for this. They had insufficient food, inadequate clothing, no psychological preparation for months of total darkness, and no experience of what prolonged Antarctic cold would do to the human body and mind. What it did was considerable. Several crew members developed symptoms of severe depression and psychological deterioration. One sailor went mad. Another died of heart failure. The ship's doctor, a young American named Frederick Cook, who would later claim, controversially, to have reached the North Pole, implemented a treatment that was unconventional at the time. He ordered the men to sit as close as possible to open fires, to expose themselves to as much light as they could generate, and to exercise regularly. He was, without knowing the clinical term for it, treating seasonal affective disorder a century before it was formally described. The crew of the Belgica survived. They were the first humans to endure the Antarctic winter, involuntarily, aboard a ship locked in the ice of the most remote ocean on Earth. They came back changed. Several of them wrote accounts of the experience. None of them, as far as the record shows, ever returned to Antarctica. Some experiences, apparently, are sufficient the first time. Some experiences are sufficient the first time. That is a quietly compassionate observation on a night like this. Not every extraordinary experience needs to be repeated to be meaningful. Some things you go through once and they become part of you permanently, without any need for a second visit. The Antarctic winter, drifting on a frozen sea in the dark, is probably one of those things. Fact 67. Antifreeze proteins and what they have given medicine. The fish and other creatures of the Antarctic waters that have evolved biological antifreeze. Proteins that bind to ice crystals and prevent them from growing inside body fluids have turned out to be extraordinarily useful beyond their original context. Antifreeze proteins from Antarctic fish and other organisms have been studied extensively for their potential applications in medicine and food science. In medicine, they are being investigated for their potential to protect transplant organs during transport, keeping tissue viable at low temperatures for longer periods by preventing ice crystal formation. They are being studied in the context of cryopreservation, the freezing of cells and embryos, where ice crystal damage is currently a significant limiting factor. In food science, they are already used in some ice cream formulations to control crystal size and improve texture. A biological solution that evolved over millions of years in the cold, dark waters of the Southern Ocean, refined by the relentless pressure of natural selection into something extraordinarily precise and effective, is now being borrowed by human technology for purposes that the fish carrying it could not have predicted. Evolution, it turns out, is an excellent research and development department. Evolution is an excellent research and development department. It has been running experiments for 4 billion years in every environment on Earth, with an effectively unlimited budget and no time pressure whatsoever. The solutions it produces are sometimes elegant and sometimes bizarre, but they are always thoroughly tested. What survives in the waters around Antarctica has been tested against those waters for millions of years. That is a level of quality assurance that human technology rarely achieves. Fact 68. The ice cores that go deepest. The deepest ice core ever drilled in Antarctica was extracted at a site called Epica Dome C on the East Antarctic Plateau by a European collaborative research program over a period of years, with drilling completed in 2004. The core reached a depth of 3,270 meters, over 2 miles, and the ice at its base is approximately 800,000 years old. It contains, in its 800,000-year record, 8 complete glacial cycles, 8 periods of ice ages and warm periods, visible in the chemistry of the trapped air and the isotope ratios of the ice itself. The record it contains is the longest and most detailed continuous climate archive ever recovered from ice. But it is not the deepest ice that exists. The ice beneath the core site continues to the bedrock far below. And in some parts of Antarctica, the deepest ice, pressed against the bedrock, warmed slightly by geothermal heat, possibly 1 million years old or older, has been identified as a target for the next generation of deep drilling projects. A project called Beyond Epica aims to retrieve ice that is 1.5 million years old. Ice that formed before the current 100,000-year cycle of ice ages began, when glacial cycles were shorter and less extreme. That ice, if it can be reached and the record within it decoded, would tell us something about why the rhythm of the ice ages changed, and by extension, something important about how the Earth's climate system responds to forcing. The answer is down there under the ice. Scientists are going to get it. It will just take a while. It will just take a while. That is the essential cadence of Antarctic science. Everything takes a while. The drilling, the analysis, the confirmation, the publication, the understanding. Everything moves at a pace set not by human urgency but by the scale of the questions being asked. You cannot rush an answer that the ice has been preparing for 800,000 years. You cannot shortcut the process by which ancient air is coaxed out of a bubble and made to speak about the climate of a world that no living thing alive today ever experienced. You wait. You go slowly. You pay attention. And eventually, the ice tells you something that changes the way you understand everything. There is, somewhere deep in the East Antarctic Plateau tonight, a column of ice approximately 3 kilometers deep, compressed and layered and ancient beyond ordinary imagining. that contains within it a record of the Earth's climate stretching back further than our species has existed in anything like its current form. And there is, somewhere in a laboratory not at Antarctica but connected to it by a chain of drilling and analysis and publication and thought, a scientist who has read part of that record and is thinking about what it means. And there is you, wherever you are, hearing a distant echo of what that record contains, a simplified, narrativized, sleep-softened version of it, and perhaps understanding, in some loose and comfortable way, a little more about the planet you are sleeping on tonight. It is a good planet, old and complex and surprising, full of rooms we haven't entered and records we haven't read and creatures doing extraordinary things in the cold dark without any witnesses. It is doing fine in its long, slow way. And so, I think, are you. We are in the deep hours now. Not just of the video, though we are that too, past the 2/3 mark, with the end beginning to come into view on the far horizon. But the deep hours of the night itself, wherever you are. The hours that have their own particular quality. Softer than the early night, looser than the hours just before dawn. The hours when the boundary between waking and sleeping becomes genuinely unclear, when thoughts arrive already half dissolved, when the voice of a narrator can become indistinguishable from the voice of a dream. That is a good place to be. Antarctica has its own version of those hours. The deep winter, weeks past the last light, when the darkness has been going long enough that it stops feeling like an absence and starts feeling like a presence. A companion. Something that has moved in and made itself at home. We are in the deep hours. Let's go a little deeper. Fact 69. The Denman Glacier and the deepest point on land. Beneath the Denman Glacier in East Antarctica, the bedrock descends to a depth that makes it the deepest point on any continental landmass on Earth. The canyon carved by the glacier, or rather the canyon that the glacier now fills, reaches approximately 11,500 feet below sea level. To put that in perspective, that is deeper than most of the ocean floor in many parts of the world. It sits miles below sea level, hidden under the glacier above it, invisible, inaccessible, pressed down by the weight of ice into a depth that no instrument has directly visited and no human has any prospect of reaching in the foreseeable future. The Dead Sea, the lowest exposed land surface on Earth, at roughly 1,400 feet below sea level, would be a high plateau by comparison. The deepest point on any continent is not a valley you can hike into or a canyon you can stand at the edge of. It is locked under ice, in the dark, at a depth that the ocean itself rarely achieves above the continental crust. Antarctica keeps its most extreme records quietly, without signs or visitor centers, without anything to mark the spot except miles of ice above and ancient rock below. Without anything to mark the spot except miles of ice above and ancient rock below. The most superlative places on Earth are not always the ones with the crowds and the photographs. Sometimes they are the ones that nobody can reach, that exist only as numbers in a dataset, as a depth reading in a radar return, as a coordinate on a map of something that has never been seen. The deepest canyon on land. Never seen. Never visited. Sitting under East Antarctica in the cold and the dark, being the deepest thing, without anyone there to tell it so. Fact 70. Subglacial sediment and what it remembers. At the very base of the Antarctic ice sheet, where the bottom of the ice meets the bedrock or the sediment beneath it, there is a thin, dark, extraordinary layer of material that has been accumulating for millions of years. Fragments of rock ground down by the movement of the glacier above. Particles of ancient soil. Microscopic remains of organisms that lived before the ice came. Before Antarctica was cold, when it was still forested and warm. This basal sediment is one of the most scientifically coveted materials in Antarctic research because it contains a record that predates the ice sheet itself, a record of the world that existed before 34 million years of glaciation began. When scientists manage to drill through the full depth of the ice and retrieve samples of the sediment below, they are reaching through the entire history of the Ice Age and touching the world that came before it. Pollen grains from ancient Antarctic forests have been found in subglacial sediment. Chemical traces of ancient soils. Microfossils of organisms that have no living relatives, because the environment they inhabited no longer exists anywhere on Earth. The basement of the ice sheet is a message from the world before the cold. It is still down there, waiting to be read. A message from the world before the cold. There was a world before the cold. That is easy to forget, looking at Antarctica as it is now, white and frozen and ancient seeming in its ice. But the ice is not the land. The ice came later. Underneath the ice, under all that accumulated frozen history, is the ghost of a different Antarctica. Green, warm, alive with creatures that left no descendants, covered in forests of trees whose relatives now grow in places like Patagonia and New Zealand, having drifted away on their tectonic plates over millions of years, not knowing they were leaving. Fact 71. The connection between Antarctica and the Amazon. Speaking of distant relatives, there is a connection between Antarctica and the Amazon rainforest that is not immediately obvious but is, once you know it, difficult to unknow. The trees that grow today in the temperate rainforests of southern South America, particularly the southern beech or Nothofagus, are closely related to trees whose fossils have been found in Antarctic rock. When Gondwana broke apart, these trees were distributed across what became South America, Antarctica, Australia, and New Zealand. Antarctica's trees died as the continent cooled, but their relatives survived and diversified on the other fragments of the supercontinent. The forests of Patagonia, at the southern tip of South America, are in a very real botanical sense the descendants of the Antarctic forests, the living remnant of what once covered a continent that is now buried under ice. When you look at a Nothofagus tree in southern Chile, standing in the cold rain at the edge of the world, you are looking at something that carries, in its genetics, the memory of a warm Antarctic forest that existed before the ice came. The tree does not know this, but the DNA does. The story is in there, written in the language of evolution, patient and precise. The story is in there, written in a language that doesn't use words, that doesn't require anyone to tell it, that simply persists, through generations, through millions of years of separation, through the drift of continents and the coming of ice, in the molecular architecture of a living thing. Everything is carrying its history. Everything alive is a living record of everything it came from. We are all, in some sense, walking archives, as faithful in our own way as the ice, as layered, as full of things that happened before we arrived. Fact 72. The Emperor Penguin's navigation. We met the Emperor Penguin earlier, standing in the dark of the Antarctic winter, holding an egg on its feet, shuffling in a slow communal rotation against the cold. But there is another aspect of the Emperor Penguin's life that deserves its own moment. After breeding, after the long walk to the sea, after the months of feeding in the open ocean, the Emperor Penguins return to their breeding colonies. And those colonies are not at the coast. They are inland, on the sea ice, sometimes 60 or more miles from open water, with no landmarks, no trees, no visual reference points of any kind. Just flat ice in every direction, and in winter darkness. And they find their way back. Unerringly, year after year, the penguins navigate across a featureless ice plain in darkness or in the low-angle light of polar spring, returning to the same colony, in some cases to the same partner, covering distances that would challenge a human navigator equipped with modern instruments. How they do this is not entirely understood. They appear to use the sun's position, accounting for its movement across the sky, as a kind of compass. They may use the stars. They may use the Earth's magnetic field. They may use infrasound, low-frequency sound produced by the ocean or by wind interacting with the terrain, as a navigational cue. They may use all of these things simultaneously, in an integration of multiple signals so seamless that we have not yet fully reverse-engineered it. They just know where home is. Across 60 miles of dark, featureless ice, they know. Across 60 miles of dark, featureless ice, they know. There is a kind of faith in that, or something that functions like faith in the absence of landmarks and certainty, in conditions where the rational case for finding your way home seems thin. The penguin doesn't deliberate. It doesn't weigh the evidence. It moves. It follows whatever internal signal it is following, across the dark and the cold and the emptiness, and it arrives. The colony is there. The partner is there. The ice is there exactly where it was. Home, as it turns out, is findable even when there are no signs pointing to it. Fact 73, the ice sheet's contribution to sea level, precisely measured. The question of how much sea level would rise if Antarctica's ice melted is one that scientists have worked to answer with increasing precision over the decades. The current best estimates are striking in their scale. The West Antarctic ice sheet, if it were to melt entirely, would contribute roughly 3.3 meters, about 11 feet, of sea level rise. The East Antarctic ice sheet, far larger and more stable, contains enough ice that its complete melting would add approximately 53 meters, over 170 feet, to global sea levels. Together, the Antarctic ice sheet holds enough water to raise global sea levels by roughly 58 meters, or about 190 feet. This is not a prediction of what will happen. The timescales for such scenarios are thousands to tens of thousands of years even under extreme projections, and the East Antarctic ice sheet in particular is considered highly stable under realistic conditions. But as a statement of what is held in that ice, what the ice represents, in terms of water that once fell as snow and has been kept frozen for millions of years, it reframes the ice sheet not just as a geological feature but as a reservoir. A vast, ancient, frozen reservoir holding a significant fraction of all the fresh water on Earth, sitting at the bottom of the world, being very patient about it. Being very patient about it. The ice is always patient. It is perhaps the defining characteristic of this continent, returned to again and again from every angle. The patience of things that operate on geological time, that measure their existence not in years or decades but in accumulations and cycles and the slow drift of continents. The ice sheet is patient. The subglacial lakes are patient. The buried mountains are patient. The fossils in the rock are patient. Even the mummified seals in the dry valleys are, in their own strange way, patient, lying in their windswept valley, going nowhere, waiting for nothing in particular, preserved indefinitely in the cold, dry air. Patience, Antarctica keeps suggesting, is not a passive quality. It is a form of endurance, a form of power. Fact 74, the unique property of Antarctic ice and how it flows. Ice under sufficient pressure and over sufficient time flows. It does not flow like water, suddenly, responsively, filling available space. It flows more like an extraordinarily thick, extraordinarily slow fluid, deforming internally, molecule by molecule, crystal by crystal, responding to gravity and pressure over timescales of years and decades and centuries. The Antarctic ice sheet is in continuous motion. The interior accumulates new snow at the top, and the ice flows outward and downward toward the edges, driven by the weight of the ice behind and above it. In the deep interior, the flow is barely perceptible, a few inches per year in some places. Near the coast, where the ice is channeled into fast-moving streams called ice streams, the flow accelerates dramatically, tens or hundreds of meters per year, sometimes more. Ice streams are the drains of the ice sheet, the channels through which the accumulated snow of the interior is eventually delivered to the ocean. They are not fixed features. They can start and stop. They can accelerate or slow down in response to conditions at their base, the presence or absence of liquid water, the nature of the sediment beneath them. One ice stream in West Antarctica, called Ice Stream C, appears to have simply stopped flowing about 150 years ago, for reasons that are still debated. The ice that was moving through it ceased to move. It went still. Nobody knows precisely why. Another mystery, sleeping in the ice, waiting for an explanation that hasn't arrived yet. Another mystery, sleeping, waiting for an explanation that hasn't arrived yet. That sentence could serve as a summary of Antarctica itself, if you wanted one. A continent full of things that have gone still, or gone dark, or gone quiet, in ways that are not fully explained, and scientists circling them slowly, patiently, with their instruments, listening for whatever signal might come through. Fact 75. The diversity of Antarctic research stations. Antarctica is home to research stations operated by more than 30 different nations, varying enormously in size, sophistication, and the conditions they expose their inhabitants to. The largest is McMurdo Station, operated by the United States on Ross Island, which can house over 1,000 people in summer and resembles, in some accounts, a small industrial town. With a chapel, a bowling alley at various points in its history, a coffee shop, a gym, and all the social complexity of a small human community placed in an extraordinary setting. At the other extreme are tiny automated stations, unmanned for most or all of the year, that simply record data and transmit it by satellite without requiring any human presence at all. In between are stations of every scale and character. The elegantly designed British Halley 6 station, which sits on ski feet so it can be towed to a new position as the ice shelf beneath it flows toward the sea. The Indian station Matri, built to withstand some of the fiercest winds on the continent. The South Korean station Jangbogo, opened in 2014 in the Ross Sea, and the Concordia station, jointly operated by France and Italy at Dome Sea on the high plateau, where the altitude and the cold make it one of the most physiologically challenging places for a human being to live on Earth. Together they represent a kind of permanent, multinational, peacefully scientific human presence at the bottom of the world. A small, cold, cooperative civilization that exists for no other reason than to understand the place it is built on. A small, cold, cooperative civilization that exists for no other reason than to understand the place it is built on. There is something genuinely hopeful in that. That 30 nations that in other contexts have complicated and sometimes adversarial relationships with each other, have maintained for decades a shared commitment to treating one continent as a place of science and peace. That people from countries that disagree about almost everything else can work side by side in the cold, sharing data and equipment and sometimes emergency resources, because the questions they are trying to answer don't belong to any one country. The ice doesn't care about borders. The climate record doesn't have a nationality. The subglacial lakes are not owned by anyone. And the scientists working to understand them have, for the most part, decided to proceed accordingly. Fact 76. The auroras and what causes them. On clear winter nights at high latitudes in Antarctica, and in the deep interior, with no light pollution of any kind and the atmosphere so dry and clear that visibility approaches its theoretical maximum, the aurora australis is something that resists adequate description. It moves. That is the first thing to understand about it. It is not a static glow but a dynamic, shifting, continuously changing display, with curtains of light folding and rippling and sometimes shooting in rays from a central point overhead in what is called an auroral corona. The colors, green most commonly, but also red, purple, blue, white, are produced by collisions between charged particles streaming from the sun and the molecules of oxygen and nitrogen in the upper atmosphere. Green comes from oxygen at lower altitudes, red from oxygen higher up, blue and purple from nitrogen. The whole display is powered by the sun, by the continuous stream of charged particles called the solar wind that flows outward from it across the solar system, and shaped by the Earth's magnetic field, which funnels those particles toward the poles. In a sense, the aurora is the place where the sun touches the Earth, where the solar wind makes contact with the atmosphere and the contact glows. It is one of the most direct and visible connections between our planet and its star, playing out in light above the ice at the bottom of the world, in the dark of the polar night, available to anyone willing to stand outside in -40 degrees and look up. Available to anyone willing to stand outside in -40 degrees and look up. That condition, the willingness to be cold, to be uncomfortable, to stand in a hostile environment and simply look. seems to be the price of admission for most of Antarctica's extraordinary experiences. The aurora, the diamond dust, the endless summer sun, the quiet of the deep plateau. None of them come easily. All of them require being somewhere that most people aren't willing to be. But then, most of the most beautiful things are like that in one way or another. They require you to be somewhere slightly difficult, to be willing to be cold, or tired, or alone, or awake when you'd rather be asleep. And then, when you are there, when you have paid the price of admission, when you are standing outside in the dark with the aurora moving overhead, you understand why people keep going back, why they can't explain it but they can't stay away, why Mawson went back and Shackleton kept going, and the scientists at Concordia volunteer for another winter when the previous one nearly broke them. The ice gives something back. It always does. It just makes you earn it first. We are in the final stretch now. Not the end, not quite yet, but the place where the end becomes visible. The place where you can feel the shape of the whole thing, can sense that the journey has been long and slow and full, and that the destination is somewhere just ahead in the dark. 24 mysteries left to find. 24 things sleeping under the ice, waiting to be lifted gently into the air and carried the last part of the way home. The night has done its work. Whatever was tight has loosened. Whatever was busy has quieted. You have been to the bottom of the world and back several times over, and the ice has become familiar in the way that only things heard in the dark become familiar. Not visually, not spatially, but in some deeper register. The ice is in the room with you now. The cold is a presence, but a comfortable one. The continent is sleeping, and in sleeping it is keeping you company. Let's finish this together. Fact 77. The Ross Sea and why it is called the Last Ocean. Off the coast of Antarctica, bordered by the Ross Ice Shelf on one side and the continent on another, lies a body of water that marine biologists and conservationists have referred to, with only slight exaggeration, as the Last Ocean. The Ross Sea is one of the least altered marine ecosystems on the planet, remote enough and ice-covered enough for long enough each year that industrial fishing largely bypassed it while it was devastating ecosystems elsewhere. The result is a marine environment that still functions, in many respects, the way marine ecosystems functioned globally before human fishing pressure transformed them. The food web is intact. The predators are present in numbers that have vanished from most of the rest of the ocean. Minke whales and killer whales hunt in waters still thick with their prey. Weddell seals haul out on the ice in densities that would have been common in other seas a century ago but are now vanishingly rare. In 2016, after years of negotiation, the Ross Sea was designated the world's largest marine protected area, covering 1.55 million square kilometers, an area larger than Iran, restricting commercial fishing across most of its extent. The Last Ocean earned a measure of protection. Not perfect protection, not permanent protection, but enough to give it a chance to remain for a little longer the thing it still is, a glimpse of what the ocean used to be everywhere before we arrived. A glimpse of what the ocean used to be everywhere before we arrived. That phrase carries both a loss and a possibility. The loss of what has already gone elsewhere. The possibility that here, at the bottom of the world, something of it has been kept. Not in ice this time. Not in ancient air or fossilized wood. But in living tissue, in swimming bodies, in the intact and functioning relationships of a food web that has not been broken. The archive, in this case, is alive. Fact 78. The Weddell seal and its extraordinary diving ability. The Weddell seal, plump, whiskered, apparently untroubled by the conditions that make Antarctica almost uninhabitable for most mammals, has evolved a set of physiological capabilities that place it among the most remarkable diving animals on the planet. Weddell seals can dive to depths of over 2,000 feet and remain submerged for over 80 minutes on a single breath. To achieve this, their blood contains extraordinarily high concentrations of hemoglobin, the oxygen-carrying protein, and their muscles are packed with myoglobin, which stores additional oxygen for use during long dives. When they dive, their heart rate drops dramatically, from around 100 beats per minute to fewer than 25, and blood is redirected away from the extremities and toward the brain and heart, the organs that most critically need oxygen. They are, in a physiological sense, a different kind of mammal during a dive than they are on the surface, operating according to a different set of priorities, with different chemistry, in a different relationship with oxygen and time. They hunt under the sea ice, navigating in the dark by echolocation, finding the breathing holes they need to maintain their access to air. They are born on the ice, live most of their lives under it, and die on it. Perfectly adapted to an environment that their mammalian ancestors never encountered, shaped by millions of years of cold water into something extraordinary. Shaped by millions of years of cold water into something extraordinary. That is, one more time, the essential Antarctic story. The story that keeps recurring in different forms, in different creatures, in different contexts throughout this long night. The cold does not destroy. The cold shapes. What survives the cold is not diminished by it but refined, pressed into forms of extraordinary precision, carrying solutions to problems that the rest of the world has never had to solve. Fact 79. The continent that absorbs carbon. Antarctica and the Southern Ocean together play a significant role in the global carbon cycle. The system by which carbon moves between the atmosphere, the ocean, the land, and living things. The Southern Ocean absorbs a disproportionate amount of carbon dioxide from the atmosphere. Estimates suggest it accounts for roughly 40% of all the carbon dioxide absorbed by the world's oceans annually, despite covering only about 20% of the global ocean surface. This absorption happens partly through physical processes. Cold water absorbs more gas than warm water, and partly through biological ones. The phytoplankton blooms of the Antarctic summer fix carbon through photosynthesis. When those organisms die, some of their carbon sinks to the deep ocean floor rather than being recycled at the surface, effectively removing it from the atmosphere for centuries or millennia. The krill contribute to this process too. Through their vertical migrations, they transport carbon from the surface to the deep ocean in their bodies and their waste. The Southern Ocean is one of the planet's most important carbon sinks, quietly absorbing a significant fraction of the carbon dioxide that human civilization is releasing into the atmosphere. It is doing, in other words, a great deal of the work of keeping the planet's carbon balance from tipping even faster than it already is. The ice and the ocean and the phytoplankton and the krill are all, in their various ways, helping, without being asked, without any awareness of what they are doing. Simply by being what they are in the place where they are. Simply by being what they are in the place where they are. There is a lesson somewhere in that, if you want one, that the most important contributions are sometimes not the dramatic ones, not the grand gestures or the deliberate interventions, but the quiet, continuous ones. The phytoplankton bloom every summer, fixing carbon. The cold water every winter, absorbing CO2 from the air. The krill every day, carrying carbon downward on their migrations. The work of the world being done steadily, without drama, without recognition, by small things in cold water at the bottom of the earth. Fact 80. The question of ancient Antarctic life and what the fossils say. The fossils locked in Antarctic rock tell a story of biological abundance that is deeply strange to contemplate, given what the continent looks like today. During the Cretaceous period, roughly 100 to 66 million years ago, Antarctica was still in a polar position but significantly warmer than it is today, with no permanent ice cap. Forests of conifers and ferns grew along its coasts. Dinosaurs walked those forests. Antarctic dinosaur fossils include a sauropod, several theropods, and an ankylosaur-like creature, all found on the Antarctic peninsula and surrounding islands. The continent was dark for months each year, as it is now, but the temperatures allowed forests to persist through the polar night rather than freezing solid. Those forests were home to creatures that have no living relatives anywhere on Earth. inhabitants of an Antarctic world so different from the current one that they might as well be from another planet. When the asteroid impact that ended the Cretaceous happened, 66 million years ago, the event that killed the non-avian dinosaurs globally, Antarctica lost its dinosaurs along with everywhere else. But it retained its forests for tens of millions of years afterward, until the ice finally came. The continent has been multiple things. It has held multiple worlds, sequentially, each one complete and inhabited and then lost. The Ice Age is just the most recent chapter. The rock remembers all the others. The Ice Age is just the most recent chapter. The rock remembers all the others. We have a tendency when we encounter things in their current form to assume that is what they have always been. That Antarctica has always been ice. That the ocean has always been as it is. That the sky has always been this color, the air this composition. But everything is in the middle of a process. Everything is a chapter, not a conclusion. The dinosaurs walking Antarctic forests had no reason to believe the forest would end. The forest had no reason to expect the ice. The ice has no way of knowing what comes after it. Everything is temporary. Everything is in transition. Everything is the current chapter of a much longer story. That is not a sad thought at this hour. It is, if you hold it right, a deeply restful one. Fact 81. The behavior of the ice at the molecular level. Ice is one of the more unusual substances in nature, and its unusual properties, the same ones that make it float instead of sink, that make it expand when it freezes rather than contracting like most substances, arise from the way water molecules arrange themselves at low temperatures. In liquid water, molecules move constantly, forming and breaking hydrogen bonds in a continuous energetic flux. When water freezes, those molecules lock into a crystalline lattice, a hexagonal structure that is actually less dense than liquid water, which is why ice floats. This density anomaly is one of the most consequential physical properties in the natural world. Because ice floats, the surface of a body of water freezes first, forming an insulating layer that slows the freezing of the water below it. If ice sank instead, if water followed the normal rules, bodies of water would freeze from the bottom up, with nothing to protect the liquid below, and aquatic life in cold climates would be largely impossible. The fact that Antarctic lake ice forms at the surface and insulates the liquid water below it, allowing those subglacial ecosystems to exist, is a direct consequence of the molecular geometry of a water crystal. The entire architecture of life under ice, the microbes in Lake Whillans, the sponges under the Filchner ice shelf, the bacteria in blood falls, all of it rests, ultimately, on the hexagonal lattice of a frozen water molecule. The smallest structure holding up the largest story. The smallest structure holding up the largest story. A hexagonal lattice, a molecular geometry, a consequence of the way hydrogen bonds arrange themselves at low temperature. And from that one small fact, an entire world of life under ice becomes possible. The subglacial lakes exist because ice floats. The microbial communities exist because the ice above them insulates. The potential for life on Europa exists, in part, because we understand this property of water and recognize it could apply there too. Everything reaches back to something smaller. Every large mystery contains, somewhere at its root, a very small and very precise physical fact. Fact 82. The ice shelf collapse and what it told us about speed. When the Larsen B ice shelf collapsed in 2002, the one roughly the size of Rhode Island, which we visited earlier in this journey, the collapse itself was startlingly fast. Most of the approximately 3,250 square kilometers of ice broke up and disintegrated into the ocean over a period of roughly 5 weeks. 5 weeks for something that had existed for at least 10,000 years. The speed was shocking not just visually but scientifically, because prior to Larsen B, many glaciologists had believed that ice shelf collapse was a slow process, that even a destabilized shelf would take centuries to fully disintegrate. Larsen B. revised that understanding dramatically. What scientists had assumed was a gradual process turned out to be capable of being catastrophic. A system held in apparent stability right up until it wasn't, and then gone with extraordinary speed. The ice shelf had been thinning for years, weakened by warmer temperatures, riddled with meltwater ponds on its surface that flexed and stressed the ice below. And then, over 5 weeks in the late summer of 2002, it simply shattered. The Larsen B collapse has since become one of the most cited examples in climate science of a tipping point, a threshold beyond which a system does not slow gradually but crosses into a qualitatively different state with a speed that the gradual preceding changes gave no warning of. A threshold beyond which change is no longer gradual. That concept, the tipping point, the threshold, the place where the system crosses from one state into another without warning, appears throughout the natural world and throughout human experience too. The moment when ice becomes water. The moment when a sleeping person finally falls asleep. The moment when something that has been approaching slowly for a long time arrives, all at once, and the world on the other side of the moment is different from the world before it. We may be approaching one of those moments now, in this long quiet night. The threshold between the last of the listening and the first of the sleeping. It is very close, but there are still a few mysteries left to find. Fact 83. The wind-carved sculptures of the ice. The katabatic winds that pour down from the Antarctic plateau are not just powerful. They are patient. Over years and decades and centuries, they carve the snow and ice into shapes. The most dramatic of these wind-carved ice formations are called sastrugi, ridges and furrows and sharp-edged waves sculpted into the snow surface by the relentless one-directional flow of the wind. Sastrugi can range from a few centimeters high to over a meter, running in long parallel lines across the surface in the direction of the prevailing wind, giving the Antarctic interior the appearance, in certain lights and from certain angles, of a frozen ocean caught mid-wave. They can make travel across the plateau, particularly by ski or sledge, extremely difficult, the surface offering no smooth passage but a continuous series of hard-edged ridges to negotiate. Early explorers described them with a mixture of awe and exhaustion. But from a distance or from above, they are beautiful. The signature of the wind written in snow, a record of the direction and force of a million storms, carved into the surface of the ice sheet in a script that anyone with a satellite can read. The signature of the wind, written in snow. Antarctica is always writing something. In the ice cores, in the sediment layers, in the radar returns from the bedrock, in the chemical signatures of ancient air, the continent is always producing a record of itself, of its conditions, of what is happening to it and around it and above it. The sastrugi are just the most visible version of this. The wind leaving its handwriting on the surface, visible to any passing eye. Fact 84. The oases of warmth near volcanic vents. In a small number of places in Antarctica, the deep geological heat of the Earth reaches close enough to the surface to create anomalies. Pockets of unexpected warmth in an otherwise uniformly frozen world. On Deception Island, a horseshoe-shaped active volcanic island off the Antarctic peninsula, the geothermal heat is so intense in places that the beach sand is warm to the touch, and in some sheltered coves, the water near the shore is genuinely warm. Warm enough, in the most geothermally active areas, to bathe in, surrounded by Antarctic scenery. The island has erupted multiple times in the 20th century, most recently in 1970, and its caldera contains a flooded volcanic crater that is one of the few places on Earth where a ship can sail inside a live volcano. Life on and around Deception Island takes advantage of the anomalous warmth. Moss and lichen grow in heated ground where they could not survive in the normal Antarctic cold. Certain invertebrates thrive in the geothermally warmed shallows. The island is a reminder that the cold is not the whole story of Antarctica, that underneath the ice and the permafrost, the Earth is still warm, still active, still capable of pushing heat upward through the crust and creating small, unexpected oases in the middle of the cold. Small, unexpected oases in the middle of the cold. That image, warmth finding its way up through the cold, creating a small pocket of possibility where none was expected. Seems like a good image to carry into the final approach. The idea that even in the most extreme cold, in the most inhospitable place, there are patches of warmth that should not be there but are. That the Earth's own heat persists, quietly under the ice. That something is always finding a way. Fact 85. The way Antarctica looks from space. From orbit, Antarctica presents an appearance unlike any other continent. The other continents are various shades of brown and green and gray, interrupted by the blue of rivers and lakes and bordered by the darker blue of the ocean. Antarctica is white, almost uniformly, brilliantly white, the ice sheet reflecting nearly everything back. From certain orbital angles in the Antarctic summer, the continent is almost too bright to process, a white shape at the bottom of the world that seems to glow with its own light. The sea ice extending from its edges during winter roughly doubles the apparent size of the continent from above, adding a vast fringe of white to the white center. Astronauts who have described their first view of Antarctica from the International Space Station often single it out as one of the most striking things visible from orbit. Not for its color or its shape, but for its sheer, absolute whiteness. A place that seems lit from within. A place that gives back almost everything the sun sends it, as though it has decided not to keep anything. As though it prefers to remain as it is. Cold, white, reflecting, returning the light without absorbing it, rather than taking in the warmth and changing. Returning the light without absorbing it. Preferring to remain as it is. There is no particular moral to draw from that. The ice is not making a philosophical statement. It is simply doing what ice does, reflecting rather than absorbing, maintaining its temperature by giving the heat back to the sky. But at this hour, in this particular kind of half-dreaming attention, images like that have a way of meaning more than their literal content. The continent that gives back the light. The place that stays cold by refusing to hold what arrives. There are people like that sometimes. Places like that. Moments like that. The image is yours to do with as you like. Here we are. The last segment. The final 15 mysteries, sleeping under the ice, waiting to be the last thing said before the silence takes over completely. There is a particular quality to final things. Not sadness, exactly. Not at this hour, in this state, in this particular kind of soft attention. More like the feeling of a long walk that has been good and is almost over, and you can see the lights of wherever you are going just ahead. The walk was worth it. The distance was right. You are tired in the way that only good, long, worthwhile things make you tired. We have covered 85 mysteries. We have been to the bottom of the world and found lakes sealed for millions of years, mountains no one has ever seen, creatures that have solved problems evolution never tried to solve anywhere else, explorers who suffered the unsurvivable and came back and went again, ice that listens to the universe, water that remembers a warmer world. We have found the largest canyon never seen, the deepest point on any continent, the coldest temperature ever recorded on the surface of our planet. And there are still 15 things left to find, but let's find them. Fact 86. The ice sheet's surprising sounds. Antarctica is often described as silent, and in human terms, no traffic, no industry, no voices, no urban hum, it is. But the ice itself is not silent. The Antarctic ice sheet produces sounds. As temperatures change and the ice expands and contracts, it cracks, sometimes with a sound like a gunshot, sudden and sharp in the still air, startling researchers who hear it for the first time. As glaciers flow over bedrock and around obstacles, they groan, a deep, low, extended sound felt as much as heard, transmitted through the ice and into the bodies of anyone standing on it. Icebergs, as they melt and shift their center of gravity and roll in the water, produce what researchers have called icequakes, seismic events detectable by instruments across vast distances, the ice announcing its own transformation. And in 2018, scientists studying the Ross Ice Shelf discovered something genuinely unexpected. The ice shelf hums continuously. The wind blowing across the snow dunes on the surface of the shelf creates a seismic hum in the ice, like the way blowing across the top of a bottle creates a note, but at frequencies too low for human ears to hear without instruments. The pitch of that hum changes when the surface conditions change. When a storm redistributes the snow dunes, or when temperatures shift, the note changes. The ice shelf is, in a precise and measurable sense, singing. It has been singing for as long as the wind has been blowing across it. We simply weren't listening. It has been singing for as long as the wind has been blowing across it. We simply weren't listening. That may be the most quietly significant sentence in this entire journey. How many things have been singing or humming or transmitting or recording or doing extraordinary things in the dark, for how long, while we were not listening, not looking, not asking the right questions, not yet possessed of the instruments to hear? Antarctica keeps answering that question the same way every time it is asked. A very long time. A very great deal. More than you thought. Fact 87. The penguin highways worn into the ice. Emperor penguins and Adelie penguins, making their seasonal marches to and from their breeding colonies, follow the same routes year after year, and over time, those routes become visible. In areas where the snow is soft enough to take an impression, the continuous passage of hundreds of thousands of small bodies over the same path wears a trail into the surface. A penguin highway, as researchers have taken to calling them, pressed into the ice by the accumulated footsteps and tobogganing bellies of generations of birds. Satellite imagery is now sensitive enough to detect these trails from orbit, and scientists have used satellite analysis of penguin highways not just to track known colonies but to discover previously unknown ones. By looking for the trails, and for the dark staining of guano that marks penguin colony sites, researchers have found colonies in locations that ground expeditions had never reached. In 2020, satellite analysis revealed several previously unknown emperor penguin colonies along remote stretches of the Antarctic coast. The penguins were there all along, marching their highways, raising their chicks in the cold, doing what emperor penguins do, in places where no human being had ever stood to watch them. They did not require our knowledge of them in order to exist. They were simply there, being themselves, in the dark at the bottom of the world. They did not require our knowledge of them in order to exist. That is, somehow, one of the most comforting facts in this entire collection. The penguins didn't need to be discovered to be real. The unmarked colonies didn't need a human witness to be full of life. The whole enormous, extraordinary, mysterious continent has been proceeding, completely, competently, magnificently, entirely without our awareness of most of it. The world is larger than our knowledge of it. Always has been. Very likely always will be. Fact 88. The strange optical phenomena of the Antarctic atmosphere. The extraordinary clarity and cold of the Antarctic atmosphere produces optical phenomena that are rarely seen anywhere else on Earth. The most dramatic is the halo system, a family of arcs and rings and spots of light that form around the sun or moon when ice crystals in the atmosphere catch and refract the light. The basic 22-degree halo, a ring around the sun at a fixed angular distance, is the most common, but in Antarctica, where the air is full of plate-shaped and column-shaped ice crystals of exceptional purity, the halo system can expand into something much more elaborate. Sun dogs, bright spots of light flanking the sun at the same elevation, appear. Circumzenithal arcs, brilliantly colored inverted rainbows near the zenith, form and fade. In the most complex displays, the sky fills with a geometrically precise architecture of light, arcs crossing arcs, halos inside halos, the whole arrangement shifting slowly as the sun moves and the crystals realign. Antarctic explorers of the early 20th century recorded these displays with something approaching religious awe, having never seen them at such complexity or frequency. Some of the most elaborate optical displays ever documented by atmospheric scientists have been observed and photographed from Antarctica. The cold and the crystals and the clean air collaborate, in certain conditions, to turn the sky into something that looks less like weather and more like mathematics made visible. Mathematics made visible. the geometry of ice crystals expressing itself in the sky, the hexagonal lattice we talked about earlier, the same molecular structure that makes ice float, that makes the subglacial lakes possible, that makes life under ice possible, manifesting at the scale of the atmosphere as arcs and halos and circumzenithal bows. The smallest structure and the largest display, connected by the same geometry, playing out simultaneously at scales separated by many orders of magnitude. Everything is connected to everything. We keep coming back to that. The ice keeps teaching it from every angle. Fact 89. The unknown viruses of the ancient ice. In 2015, scientists studying ancient ice cores from the Tibetan Plateau, and similar work has been conducted with Antarctic ice, discovered something that opened an entirely new dimension of what the ice is preserving. Ancient viruses. Dormant, frozen, preserved in the ice for tens of thousands of years. Viruses unlike any currently catalogued, representing genetic material from microbes and pathogens of a world that no longer exists in its previous form. In Antarctic ice cores, researchers have identified genetic material from viruses dating back hundreds of thousands of years, most of them unknown, not matching any virus in any database, representing lineages of pathogen that may have infected organisms alive during previous glacial periods. Most of these ancient viruses would pose no threat to modern life. Their hosts are long gone, or the viruses themselves have been rendered non-functional by the millennia of freezing. But the discovery raises a genuine scientific question about what else the ice is holding. What other genetic material is preserved in the deep, cold dark of the ice sheet, waiting in a dormancy that the ice has maintained faithfully for a very long time? The archive, it turns out, contains things that were not deliberately deposited. The ice collected everything that fell on it. Everything. Without discrimination, without selection, without any awareness of what it was keeping. Without any awareness of what it was keeping. The ice did not choose to preserve ancient viruses, or volcanic ash, or microplastics, or neutrinos, or ancient air. It simply accumulated, layer by layer, and kept whatever arrived. The fidelity of the archive is not a result of intention. It is a result of cold and pressure and time. The most comprehensive record of the Earth's recent history was made by something that has no awareness of history at all. Perhaps that is how the best records are always made. Fact 90. The deep time of the southern ocean floor. While the ice sheet above is ancient by human standards, 34 million years old, the sediment on the floor of the Southern Ocean is older still. The deep ocean floor around Antarctica contains sediment cores that have been drilled and analyzed to reconstruct the history of the Southern Ocean itself. Its temperature, its chemistry, its biological productivity, its circulation, going back tens of millions of years. These sediment cores have revealed, among many other things, the moment when Antarctica's glaciation began, the precise layer in the sediment where the chemistry changes, where the signature of ice-rafted debris first appears, where the microfossils of warm water organisms disappear and are replaced by cold water ones. The moment the ice came. Recorded in the mud at the bottom of the sea. Approximately 34 million years ago, the world around Antarctica changed, and the change is written there in the sediment in a layer a few centimeters thick between the world before and the world after. Scientists who have held those sediment cores and identified that layer describe it as one of the more extraordinary experiences in paleoclimatology. Holding in your hands the actual physical boundary between two worlds. The before and the after, separated by a thin stripe of ancient mud. The before and the after, separated by a thin stripe of ancient mud. That is what a threshold looks like in geological time. Not a wall. Not a sudden break. A thin stripe of transition, a few centimeters of sediment, a change in chemistry. And on one side, a warm world with forests and warm water organisms and no permanent ice. And on the other side, everything we know Antarctica to be. The whole 34 million year story of the ice, beginning in a layer thinner than your finger. Fact 91. The continent's effect on global weather patterns. Antarctica does not merely experience weather. It makes it. The temperature difference between the cold Antarctic continent and the relatively warmer mid-latitudes drives the polar vortex, a large, persistent area of low pressure and cold air that spins around the pole, contained by the polar jet stream. When the polar vortex is strong and well organized, it keeps the coldest Antarctic air locked near the pole and the weather systems of the mid-latitudes relatively stable and predictable. When it weakens or becomes disrupted, which happens periodically, and appears to be happening with increasing frequency as the atmosphere warms, the cold air can escape southward in great lobes, sending blasts of polar cold far into the middle latitudes and disrupting weather patterns across large regions of the southern hemisphere. Changes in Antarctica's temperature and ice cover affect the temperature gradient that maintains the polar vortex, which affects global weather in ways that are still being fully mapped. The butterfly effect, in this case, is an entire continent of ice influencing the circulation of the global atmosphere. The cold at the bottom of the world does not stay at the bottom of the world. It moves. It reaches. It shapes the weather in places that have never seen a glacier and never will. It reaches. It shapes. It moves through the world quietly, through mechanisms most of us never think about, influencing weather in places that feel nothing like Antarctica and have no obvious connection to it. The continent is more present in our lives than most of us know. In the carbon it absorbs. In the weather it drives. In the ocean circulation it powers. In the light it reflects back to the sky. Antarctica is not just a remote place at the bottom of the world. It is a fundamental operating component of the planet that all of us, everywhere, live on. We just forget that most of the time. Fact 92. The animals that winter in total darkness under the sea ice. While emperor penguins famously breed in the Antarctic winter darkness on the ice above, beneath the sea ice, in the cold dark water, creatures carry on with the business of survival in ways that are only recently being understood. Weddell seals maintain breathing holes through the ice by scraping them with their teeth, a habit that wears their incisors to stubs over a lifetime. Antarctic toothfish, those enormous slow-growing fish we visited in the Southern Ocean, move to deeper, darker water in winter, slowing their metabolism to match the season, living off stored energy. And remarkably, Antarctic krill, those small crustaceans on which the entire ecosystem depends, have been observed spending the winter under the sea ice, grazing on the algae that grows on the underside of the ice itself. In a world without sunlight, without the productive surface blooms of summer, the krill find their food on the ceiling of their frozen world, scraping ice algae from the underside of the sea ice with specialized feeding appendages, sustaining themselves through the dark months on what grows in the dark, on the bottom of the ice in the cold. They do not wait for summer. They adapt to winter. They find what is available and they use it. The Antarctic winter does not pause the ecosystem. It redirects it. The Antarctic winter does not pause the ecosystem. It redirects it. That is a principle that extends well beyond Antarctica. Difficult seasons do not stop living things. They redirect them toward different food sources, different strategies, different depths, toward the algae on the underside of the ice, the resource that nobody else is using, the solution that only becomes visible when everything obvious has been taken away. Fact 93. The search for oldest ice. The ice core record currently extends to 800,000 years. The Epica Dome sea core we discussed, with its 8 glacial cycles and its ancient trapped air. But scientists believe that somewhere in Antarctica, even older ice exists, ice that could extend the record to 1.5 million years or beyond, capturing a period in Earth's climate history when the rhythm of the ice ages was different. The project to find and retrieve this ice, called Beyond Epica and also Little Dome Sea, involves identifying a location where the ice is deep enough to contain 1.5 million-year-old layers, but where the flow of the ice has not folded or disrupted those oldest layers beyond reading. The base of the ice sheet, as we noted, is where the oldest ice is, but it is also where the ice is warmest, where it is most deformed by flow, where it is most difficult to read. Finding a location where the oldest layers are preserved intact requires a precise combination of ice thickness, flow rate, geothermal heat, and bedrock topography. Scientists have identified candidate sites using radar surveys and ice flow models and are moving toward drilling. The oldest ice on Earth, containing air from a world that existed before the current pattern of ice ages, from a time when the Earth's climate system was behaving differently than it has for the past million years, is down there somewhere, preserved and waiting, at the bottom of a column of ice in East Antarctica. The question of what it will tell us when we finally reach it is one of the most anticipated open questions in climate science. One of the most anticipated open questions in climate science. And when the answer comes, when the drill finally reaches that oldest layer and the ancient air is extracted and analyzed and the record is read, it will tell us something about a world that existed before our species, before our genus, before anything recognizably human walked on this planet. Air that was trapped before the current ice age cycle began, from a world that was different in ways we can only currently model and project. The ice will tell us what it was actually like. The difference between the model and the reality will teach us something. It always does. Fact 94, the people who have never left Antarctica. This is not a fact about the living. It is a fact about the dead, about the small number of people who died during the early expeditions and were buried where they fell on the continent in the ice and the rock. There are graves in Antarctica. Simple ones, mostly. Cairns of rock, wooden crosses weathered by decades of Antarctic wind, small markers left by expeditions that lost someone and had no way to bring them home. Some have been eroded by the wind to near invisibility. Others have been maintained by subsequent expeditions that passed by and paused to add a stone or re-erect a cross. The most visited is probably the cross erected on Observation Hill near McMurdo Station, overlooking the Ross Ice Shelf, placed there in 1913 by the surviving members of Scott's expedition, in memory of Scott and his 4 companions who died on the return from the pole. It is made of Australian jarrah wood and carries a line from Tennyson's poem Ulysses: to strive, to seek, to find, and not to yield. It has stood there for over a century, in the Antarctic wind, overlooking the ice shelf that the men crossed on their final journey. They are not buried there. Their bodies were found in their tent on the ice shelf, which has since flowed into the sea, carrying them with it. But the cross remains on the hill, in the wind, looking out over the route they took. A marker for people who are somewhere under the Ross Sea now, having traveled with the ice all the way to the ocean. Antarctica keeps its dead in the end, as it keeps everything, patiently and in motion and going somewhere. Patiently and in motion and going somewhere. That cross on Observation Hill has been standing for over 100 years in one of the windiest places on Earth. The wood has endured conditions that should have destroyed it, and it looks out over an ice shelf that is itself in motion, flowing slowly toward the sea, carrying within it the memory of the men who crossed it and did not come back. Everything in Antarctica is in motion, even the things that look still. Fact 95, the microbes that eat rock. In the dry valleys, where there is no soil in any conventional sense, just bare rock scoured by wind, baked by UV radiation in summer and frozen solid in winter, life has found a way that seems almost willfully determined to exist in defiance of everything reasonable. Certain communities of microorganisms, cyanobacteria, algae, fungi, live not on the surface of the rocks but inside them. Just below the translucent surface of certain rocks, in a thin zone where a tiny amount of light penetrates but the worst of the UV radiation and the temperature extremes are buffered by the rock itself, these organisms have established themselves. They are called endolithic communities. Endo, meaning within, lithic, meaning rock. They photosynthesize in the faint light that filters through the rock's translucent surface. They extract water from the rock itself. They grow at rates so slow that a single millimeter of colonized rock may represent centuries of biological activity. They are, in the most literal possible sense, living inside the walls of Antarctica, inhabiting a zone between the outer surface and the inner darkness of the rock, finding in that narrow margin enough light and enough water and enough chemistry to persist. When scientists first discovered them, by slicing open rocks in the dry valleys and finding unexpectedly green interiors, they recognized immediately that this was another existence proof, another demonstration that life will find the available niche, however narrow, however improbable, however demanding. Life will find the available niche, however narrow, however improbable, however demanding. That has been the recurring discovery underneath Antarctica and inside its rocks and in its saltwater glaciers and in its buried lakes and in its freezing ocean throughout this entire long journey. Life is not fragile. Life is not the exception. Life is, apparently, what happens whenever the basic conditions allow it. And the basic conditions Antarctica keeps demonstrating are less restrictive than we thought, less dependent on warmth, on light, on the particular range of chemistry we are accustomed to thinking of as necessary. Life finds a way. We have heard that said so many times that it has become a cliché. Antarctica makes it feel like a discovery again. Fact 96. The iron fertilization of the Southern Ocean. One of the more surprising scientific discoveries in recent decades concerns the relationship between iron, a simple metal, common in the Earth's crust, and the productivity of the Southern Ocean. Phytoplankton require iron to grow, as they do all nutrients, but in the open Southern Ocean, iron is the limiting factor. The nutrient that runs out first and caps how much phytoplankton can bloom. The iron that does reach the Southern Ocean comes from several sources. Some is carried by wind from distant continents, dust from South America and Australia, blown far out over the ocean. Some comes from glacial meltwater, carrying iron weathered from Antarctic rock. And some, a surprisingly significant amount, comes from icebergs. As icebergs from Antarctica melt, they release iron that was incorporated into the ice when glaciers ground over bedrock and picked up mineral particles. A single large iceberg, as it drifts northward and melts over months or years, releases a continuous slow drip of iron into the surrounding water, seeding phytoplankton blooms that are visible in satellite imagery as green halos around the drifting ice. The icebergs are not just frozen water. They are iron delivery vehicles, slowly, silently fertilizing the ocean as they dissolve. Antarctica sending nutrients to the sea, even as it melts. Antarctica sending nutrients to the sea, even as it melts. Even in its dissolution, the ice is giving something. Even as it shrinks and drifts and releases the water it has been holding for centuries, it feeds the ocean that surrounds it. The icebergs become blooms. The blooms become krill. The krill become whales and penguins and seals. The melting of the ice is not only a loss. It is also a gift, however complicated the circumstances of its giving. Fact 97. The telescope at the end of the world. We mentioned the IceCube neutrino detector buried in the South Pole ice. But the South Pole is home to another extraordinary instrument. The South Pole Telescope, a 10-meter diameter microwave telescope sitting on the polar plateau at nearly 10,000 feet of elevation, in the driest and clearest atmosphere on Earth. It has been used to study the cosmic microwave background, the faint, ancient light left over from the Big Bang, still filling the universe in every direction, carrying information about the first moments of cosmic history. But the telescope has also been used to survey galaxy clusters, the largest structures in the universe, by detecting the subtle way they distort the cosmic microwave background as the ancient light passes through them. This technique, called the Sunyaev-Zeldovich effect, allows the telescope to find galaxy clusters that are too distant and too faint to detect invisible light. Clusters of hundreds or thousands of galaxies, each containing hundreds of billions of stars, visible from Antarctica as subtle shadows in the oldest light in the universe. From the bottom of the Earth, surrounded by ice and cold and the long polar night, we are mapping the largest structures that exist. The scale runs from the molecular lattice of a snowflake to the clusters of galaxies, and Antarctica sits in the middle, looking in both directions at once. Looking in both directions at once. From the molecular to the cosmic. from the hexagonal ice crystal to the galaxy cluster, from the bacterium in the subglacial lake to the neutrino from a distant black hole. Antarctica contains multitudes. Fact 98. The future of the frozen continent. Scientists who study Antarctica professionally tend to hold two things simultaneously: a deep, sometimes overwhelming love for the place, and a clear-eyed understanding of the changes that are underway and the ones that are coming. The ice is retreating in some places. The ocean is warming. The West Antarctic ice sheet is under pressure it has not experienced in human history. The Thwaites Glacier is being watched more carefully than perhaps any glacier has ever been watched. And yet Antarctica is not simply a story of loss. The ozone layer is recovering. The Ross Sea is protected. The Antarctic Treaty has held for over 60 years. The whale populations are recovering. The science is advancing rapidly. Each year bringing new instruments, new techniques, new data, new understanding. The Beyond Epica drill will eventually reach the oldest ice. The mystery of the Denman Canyon will eventually be better understood. The subglacial lakes will eventually be more fully explored. Antarctica will continue to be what it has always been, a place of secrets, slowly yielding them on its own schedule to the patient and the persistent. The future of the frozen continent is not written. It is being written, right now, in the decisions of the present, in what is protected and what is not, in what is measured and what is ignored, in who chooses to go to the bottom of the world and ask what it knows, in who chooses to go to the bottom of the world and ask what it knows. Perhaps that is all that science is at its root. The decision to go somewhere difficult and ask questions. The willingness to be cold and patient and precise, to listen to the ice and read the sediment and decode the ancient air, to be present with the mystery without requiring it to resolve itself before you are ready. Antarctica rewards that. It has been rewarding it in the people who have gone there for over 2 centuries now, and it will keep rewarding it for as long as there are people willing to make the journey. Fact 99. The ice that is older than the question. Somewhere deep in the East Antarctic ice sheet, at a depth not yet reached by any drill, in a layer that has not yet been sampled or dated or analyzed, there is ice that formed before human beings asked the first question about the natural world. Before the first philosopher looked at the sky and wondered why it is the way it is. Before the first astronomer noticed the patterns in the stars. Before the first scientist, whoever that was, whenever that was, wherever that was, looked at the world and felt the specific pull of wanting to understand rather than merely to survive. The ice was forming before the question existed, and it will still be there in some form long after the question has been answered. There is an ice sheet and there is a species asking questions about it, and the ice sheet will outlast the questioning. It has outlasted every species that has ever walked the land it rests on. It has outlasted the forests and the dinosaurs and the warm seas and the creatures whose fossils are in the rock below it. It simply continues, building, flowing, preserving, recording, singing in frequencies too low to hear, while the questions come and go around it. That is not a bleak thought. It is a stabilizing one. The ice is larger than the urgency. The cold is older than the worry. The continent will be there tomorrow, and the day after that, patient and full of mysteries, waiting for the next question. Fact 100. The feeling of standing on the ice. And the last mystery, the 100th, is perhaps the simplest and the strangest of all. Every person who has ever stood on the Antarctic ice sheet, on the plateau in the deep interior, far from any coast or station, with nothing in any direction but white, has reported the same thing. Not fear, though there is that too. Not cold, though there is plenty of that. But something else. Something that is very difficult to put into words, which is perhaps why so many people have tried and so few have felt they succeeded. A feeling of scale. A feeling of deep geological time pressing against the soles of your boots. A feeling that the ordinary coordinates by which you locate yourself in the world, in time, in space, in the hierarchy of what matters, have dissolved quietly and completely, leaving something beneath them that is cleaner and simpler and very hard to name. Some people have called it peace. Some have called it terror. Some have called it both simultaneously, in proportions that shift with the light. Robert Falcon Scott wrote, in the journal recovered from his frozen tent, that Antarctica is a place where the soul is tested and sometimes, in the testing, finds something it did not know it had. Apsley Cherry Garrard, who survived the worst journey in the world, a midwinter trek in total darkness to collect emperor penguin eggs, wrote that if you have the desire for knowledge and the power to give it physical expression, then go out and explore. And Douglas Mawson, who survived what should not have been survivable, who came back changed and diminished and altered, and then went back. Anyway, never fully explained why. He didn't have to. The going back was the explanation. Antarctica asks something of everyone who encounters it, even from a great distance, even in the dark, even through the medium of a quiet voice on a long night. It asks you to hold something large and old and indifferent and extraordinarily beautiful, all at once without resolving it, without making it smaller, without looking away. And in return, it gives you the feeling, brief and strange and not quite like anything else, of being part of something much larger than yourself, which is perhaps the oldest and most reliable cure for whatever is keeping you awake. The ice is there at the bottom of the world. The lakes are sealed. The mountains are buried. The wind is pouring off the plateau. The penguins are standing in the dark. The ice is singing in frequencies too low to hear. The neutrinos are passing through everything on their way from somewhere impossibly far away. The icebergs are drifting north, carrying their iron, feeding the ocean as they dissolve. The oldest ice is waiting to be found. The cross on Observation Hill is facing into the wind point. 100 mysteries have been found, and lifted gently from the cold, and brought here to this room, this night, this particular darkness that is yours. They are all still there, back under the ice, precisely where we found them. The finding doesn't diminish them. The telling doesn't empty them. They will be just as mysterious tomorrow as they were tonight. Fuller, if anything, for having been looked at. That is the nature of real mysteries. They don't wear out. They just wait, patiently, in the cold, in the dark, at the bottom of the world. Good night.